Hey, welcome. Part 26. Let's make our little announcement. I'm ready to get started today. Let's not forget the link this time. How about that? That would be good. And we're doing more compiler. What do you know? We're gonna do the terrible what do you. What do you know? Part 26. Gonna at the notification squad. I don't know what to call you. The notification group. We've been having great discourse today, this morning, and it's been a ton of fun. C handles all your stack-based allocations, right? Then there's like runtime, I don't remember what this stands for, RAI and CPP to manage heap stuff. Int, pointer, make an array please, int n, int pointer malloc n times size of int. There's literally calloc though, which is made to allocate arrays. I'm doing it. Versus OBRM on the Rust side. RPWH, you're very smart. Also Nick. Yo, Lens, I'm first. Lol. Got him. Nick is absolutely first. Hello, Nick. How's it going? It's great to see you. Thank you for tuning in on this fine morning. At least morning for me. Maybe afternoon. So instead of managing every piece of memory, pull a region of memory for a certain task and have it assigned. Then when said procedure task is done, you don't have to worry about all the pieces. You can just yeet the entire arena. Nope. Yep. Correct. Basically, he's saying nope, not when the procedure task is done, but you don't have to worry about all the pieces. You can just yeet the entire arena. That's correct. But this part's pulling a region of memory for a certain task and have it assigned. You don't really need to have it assigned. You just yeet it when it's done. That's it. It's perfect. It's a great way to say it. RPWH says, yeehaw, how's it going? Our prime contributor for the week. RPWH, how's it going? We love you around here. Thank you so much for tuning in. Good morning or good afternoon, whatever time it is for you. Hopefully it's good. We got an oldie but a goodie. Eternal Wild Fox is in here. Hello. How's it going? We should, I guess, just get right into it. So I went a little crazy last night, thinking about things, and I ended up writing 4 pages of notes. So I have them here, and we're just going to, while org mode loads, I'm just going to look over them and kind of give you the gist. Lil Weech says, hello, Lens, sorry for trolling. Lil Weech trolled? I don't remember trolling by Lil Weech. Don't worry about Lil Weech. I don't even remember. You don't need to be sorry. RPWH says, I underestimated how big a task to lubing 80 switches is. Oh lord. That sounds, yeah, that's a lot. I think even doing one for me, it would take me like an hour. My hands are so shaky. Nick says, Lens need custom BTTV emotes, to be honest, for some funny things, lol. It's true. I should look into that. Eternal Wild Fox says, doing fine, making progress on my Pratt parser. How are you doing? Thanks for asking, Eternal Wild Fox. I'm doing okay. I've had a good morning. And I woke up, so, you know, doesn't get much better than that. RPWH, I feel so bad for you. You have to lube 80 switches. I think I could get through 1 an hour, maybe 2. You should see me solder. It's like this. It's like watching a grandma walk across the street. It's like, oh my god, this is slow. Luigi says, I am Luigi trolling Malik. Ah, no, it's not troll. It's beautiful. It's beautiful. No harm done. This you? This is beautiful though. Because it points out that like, oh, this wouldn't be the right thing to do. Because some people do write code like this, believe it or not. So it's good to point out like, oh yeah, do this, yep. Because nobody would take this seriously. And if they do, I'm I said something right after, so it's okay. People will know, like, ooh, what's calc? And then they'll look up calc and realize, ooh, it has an and a size. Also, the size of pointer is amazing. I love allocating the pointer. It's pretty great. Halfway into the if statement. Ooh. Ooh. Eternal Wild Fox, you're doing amazing. RPWH says, I'm like 50 in, lol. Only took about 4 hours. Oh no. I'm so sorry. Rest your weary hands. Don't get carpal tunnel. It's just a keyboard. My face when Luigi makes calc again. Up next, making the wheel again. Calc where the pointer is allocated. It's one of my favorite. You get a bunch of pointers instead of actually. It's so silly. It's really silly. In any case, we have a lot to do, and we're probably just going to make things worse today and break just about everything. How does that sound? Let's make sure our Git is pretty clean so we can do a stash if we need to. I'm okay with losing all these comments. We're good. Nick says, so goofy, Luigi, lol. Sounds like the average day of working on anything ever. Lol, lol, lol. Okay, so I guess that we just gotta get right into it. We're gonna work on the funarg problem today. I think we're finally at a place where we can break everything, because everything seems to be working. We can make sure of that everything builds and runs, and what example should we feed it? Let's just feed it greatest common denominator. That's one we've been doing. Oh, I know what to do. I'm in the wrong spot. There we go. See how it goes. Perfect. We'll clean first every time, just so we do a complete rebuild. RPWH says up, down, or both. We're gonna solve the downwards funarg problem today. RPWH, I love that you know about it. And the upwards funarg problem we're gonna work on next, because I have a solution. We're just gonna introduce basically a lonely function. I don't know what to call it, but just a function that only accesses things within its own scope or within the global scope. And those functions will be able to be called from anywhere, even if you pass them around. So those functions will be like type checked to ensure that they don't access the wrong scope. And in doing so, we'll be able to return them as functions, or return the functions as arguments. And today, this will be a large part of that. This will be a large part of that, because currently we have functions treated not as first-class citizens. Let's take a look at the many ways in which they are not. One, they have their own node type. You would think that if a function is just a variable, then it would just be a variable declaration, an access, right? A reassignment. There would never be any specific function code, because all of it, a function is just a variable. Nick says, global funcs, are they not just called global functions? They are not. They're called lonely because there's some, you'll see. You'll see. We're gonna, basically, if we go to, I don't know if we have it here. So the problem with the upwards funarg problem, the problem with the problem is the problem. So the upwards funarg problem, for example, Pascal does not allow returning functions as values from other functions. But we would like to be able to do that. But the problem is that obviously these local variables won't be in scope when this function returns, because the scope, the stack frame will be removed. And then where do these variables actually go? They're lost after this function call. And then during this function call, it tries to access a stack address that does not exist. Not good. So a lonely function is going to be a nested function, for example, and the nested function is going to be type checked. It'll be like defun lonely. This will not be the syntax, but for example, something like this, if we had keyword syntax. So defun lonely adder implementation, then this would be type checked and the compiler would create an error and say, hey, lonely functions cannot access anything outside their own scope. And this has to go up to this scope to access these variables, so you're doing something wrong. But if it's lonely, then you would be able to do things like return it as a value from a function. And if it's not lonely, you wouldn't. So we're going to have like type attributes of functions. And even global functions, you're right, could always also be called. Nick says, makes sense, makes sense. Yeah. Perfect. And then the downwards funarg problem. The idea is that we want a function to just be defined like a variable. So this is going to be a type, a single type, all of a sudden. So in our parser, when we parse a type, where is that little bugger? There it is. Track you down. There we go. This is what we do when we parse a type. Currently, we just loop over all the pointer declaration symbols, and then we get the symbol after that, and we ensure that the symbol is a type, a valid type. So, for example, when we find a type annotation operator, we then try and parse a type. And if the type we parse is @integer, then this is a pointer to an integer. But what we would like to do is say, when we parse a type, if you see a paren, then that's actually a function type that returns this and has these parameters. So our function signatures are going to become part of our type system. And then we're going to have an expression which generates these functions. Generates is a bad term. I should say returns, because an expression returns a value. So for example, the expression 5 returns the value, integer value 5. 5 plus 5, the expression is plus, and 5 and 5 are the children. And effectively, the result, the return value, is an integer value. So we want to have some sort of expression, some function expression, that generates this type as a return value. And it must have, obviously, all this information within it. Otherwise, where would we get this information from? It'd have to be like type inferred, and we don't want to do that. We want to have statically typed and declared variables. So the idea is that this little ditty here becomes an expression in its own right, right? So we have our function name, which is just a variable, right? Our variable name, which is a function. This is terrible, but bear with me. And this will have some function signature as its type. And then we're going to say it's equal to some expression that will probably be formed in the same way, but with a body following it. And this will be how functions are defined before we fix our syntax. So before you say, oh my god, this is terrible, please, we're going to fix it. And we're going to get to the point where we get here, because that'll just be a parsing shortcut that we put in afterwards. Once we figure out, okay, we can parse a lambda, effectively, is what this will be, because a lambda is an expression that returns a function, sort of. It is a function, but you can create them through It's hard to explain. Nick says, I think defining the signature twice is stupid. Me too, buddy, me too. So what we're going to do is have a lambda that has the signature and the body, because this lambda will have all the type information it needs to be type checked and ensure that this function can match it. which I think is a good way to go about things. Nick says lambdas. It's true. We're doing lambdas. And then what we're going to do eventually is be able to parse a lambda directly after a type annotation operator for a variable declaration. And this will allow us to not have this entire syntax. We could just do that, right? It'll happen eventually. But for now, what we're going to focus on to get this working is this syntax right here. Because this will allow us to more easily integrate it into our current system. We have a variable declaration, so we just need to extend parse type to actually parse function types and go, okay, if you see an open paren, that means this is actually a return type of a function, and then parse all the parameters, please. Lil Weege says, so does the variable function capture globals or other functions? Does the variable function capture globals or other functions? Capture. I'm not sure what capture means. It'll be within the global scope, which means it can access everything that's been defined since. So like if we had an integer here, that was called x, so we don't have a shadowing issue. Let's say x is equal to 69, right? Then it's an integer. You could absolutely use x in here is the idea, because this is going to be what's called a strong function. I don't know how we're going to deal with this, but this is going to be a strong function, and that means that it has a body. It's been assigned an actual valid thing, so this variable is now callable as a function. It's going to be a lot of type checking, but effectively this lambda, the idea is it's going to be lonely, but it will be able to access outside of itself. It just means that accessing something outside of itself will ensure that it's a strong function, which means this can't be reassigned and it will become immutable. Rohan says a lot of type checking and a lot of child labor. You're correct. There's going to be a lot of children in our type system very soon, because there's no other way to store all this type data in one node. Unless you have an idea, but I don't, just how to store all these in one node. So our type system there's gonna be some child labor going on. Also, how's it going, Rohan? Good evening. It's great to see you. Thank you for tuning in. I very much appreciate it. Good evening, good afternoon, and good morning. Lil Weege says, okay, and can it use other functions like sumAdder? Can this use other functions? Thinking about it, so it will only be able to use them if they're callable in this scope, and it should be callable in this scope, because sumAdder would be a strong function because it has a body. So the idea would be that strong functions are immutable and can never be reassigned and will always be callable, is the idea that we're trying to ensure. So sumAdder will always be callable, and that means we can just call it from anywhere. So yeah, sumAdder should be absolutely usable. We just have to do something like that, right? Because sumAdder should be callable within this scope. Lil Weege says, I see, thanks. But again, we're getting there, and this is going to be a complicated thing. We're also going to have to change our entire code gen. We're going to have to do a lot. I think the first thing to do would be to create a simple example. So I'm going to do downwards funarg. I'm just going to do downwards funarg. Let's just do that. And say, let's load unmode and say, downwards funarg problem is the problem in computer science. It's a little wordy, but it's fine. Problem in computer science where functions are passed as arguments to other functions. And that's it. And that's what we're working on. So we would like to create a function and have its type be parsed as a function. Let's start there, right? So we're going to say currently, how we create a function is with the fun, but we're changing that and saying, no, functions are variables, and a function signature is a type, which is a little bit of a shock to my mental model, but I understand why it's needed, and I think it's totally doable. So let's have our sum function. We're just going to call it foo, and it's going to return an integer and nothing else. We are going to also have bar, which is an integer that takes in an integer argument and is defined right away. And again, we're going to have to write this twice. I understand it's terrible. I'm sorry. I guess I can just do this. Nick says, I like the syntax, to be honest, without the repetition. Yeah, you can see if I didn't have to go back through and copy paste there, this would actually be usable. But we're not there yet. We're not there yet. So the idea is we're going to do this. So we want foo to be a function which returns an integer. That's all we're trying to parse at the moment. So we're going to go back to to-do, so we're in the proper working directory, and then change our little example we're using. Make it a little bigger so you can see it. And we're going to use the downwards funarg. And perfect. Invalid syntax, unknown symbol. So we get this symbol, which is an open which is an open parenthesis, and it says, hey, we don't know what this is. First time chat from a new viewer. King Buns, you've been active in the Discord. It's great to see you in the live chat. Will this essentially be making functions first-class citizens? That is exactly what we are doing. And that is what the funarg problem is all about. Today we're solving the downwards funarg problem. That's a little hopeful. Today we are trying to solve the downwards funarg problem. Adderson28 says, hi Liz, hi chat, how are you doing? We're doing okay. We're having a ton of fun. How are you doing, Adderson? It's great to see you. Thank you for tuning in. Lil Weege says also, do you plan on having types being first class? Yeah. Eventually. I don't even want to think about that right now because that breaks my brain a little bit, but yeah, eventually. Eventually. Types are going to be, we're going to have like a type generic class, and a type is going to be able to be assigned to like integer, right? So you're going to have like my type, right? It's going to work like that. So you're going to have like, oh, this is my type, and it's a type, and it's the integer type. But I don't even want to think about the semantics of that right now, because it's going to hurt my brain. Currently, we're just going to parse a function signature as a type. Hey, look, I left myself a little to-do last night. Nick says, good luck, lol. Yeah, that's, I know, it's ambitious. It's ambitious. I wish I could speak English. Adderson28 says, I'm fine, studying a lot, lol. Oof. I'm sorry about that. Hopefully this doesn't distract you too bad. Lil Weege says, brain bending. Yeah, it's like, oh, a variable which has a type, and the value is a type. It gets to like nested, like recursion problems, but your type recursion, which is just hideous. But we're gonna have it. It's gonna be here. Okay, so we're gonna expect. I don't remember how to expect. I think we can expect. We don't have everything we need to expect. We're gonna need a little expected. Again, this is the worst way to do this, and I'm sorry. So we're going to pass expected. We're going to need current. We're going to need length. We're going to need end. What's the why? 2. Oh, you guys can't see that. Too few arguments provided to function like macro invocation. Macro expect defined here. There's too few arguments? Oh, the thing I'm expecting. That might be important. Lol. There's still more issues. See, I thought I didn't need a pointer. But it said I needed a pointer. It says char pointer expected, but that's lex expect. Ah, see, that's not the macro expect. That's the function. That's the function that the macro calls. This is crazy. There's some real macro replacement going on here by the language server. That's intense. So if we find this bad boy, that's pretty good. No, what does that mean? So what does this mean? What is our type? What is our type? We have a node pointer type, and I'm sure that we've set the pointer in direction level, and we've set it to a symbol. So we have some valid type symbol. Also, oh, this is fine. We're freeing the node pointer itself and not its contents, which we've copied into type. This is a little scary, having these frees here. I was like, ooh. Okay, so then, if we find an open paren, that means we have a function. And that means our type symbol is actually a return value of a function. So we're going to say actual type. That's a terrible name. We're going to say function type. And it's going to be a node symbol, which just says function. And we're going to say node add child to this function type. And add type as a child to it. But that uses directly the pointer, and we need this pointer to be overwritten with itself. I don't know if I'm making sense, but it is true. So we're going to have return type, and we're going to have to copy type. Okay, we're going to have to node type equals node allocate. Always forget. And then we copy from type into return type, because this is now a return type. Then this is now type, so type is already a symbol, but the symbol value is going to be equal to function. So we're going to have to this is confusing. So we've copied this, we need to free it, and then update this. Okay, yeah. We need to node free without freeing type. Oh man. Well, I guess what is there to free? So it's a symbol. Type is a symbol. And we've copied it. So now we need to free the symbol before we reassign the symbol. But we're just going to reassign the whole thing. Oh, this is horrible. I'm sorry for making you look at this. We got there in the end. That's rough. That's rough, everybody. Nick says, what the fuck is going on? Remember when they were talking about malloc and free and everything? This is what they were talking about. So, in the Discord, here's the issue. We have a type, and this pointer is effectively given to us, so we need to write our result into this pointer no matter what. And it currently holds our working result, which is our return type. So we allocate a return type, right? Also, look at us. So we allocate a return type, and then copy the return type of the function, which is currently in type, into return type. Now type is just a symbol. That's what this means. It may have pointer and direction, but it's just a symbol. So all we need to do is replace that symbol with a new symbol, but that's kind of hard to do. We need to heap allocate a new symbol and free the old one. So that's exactly what we do. We free the old symbol, we create a new heap allocated symbol, we copy that symbol into type, and then we free the node, which is like the shell, right? We don't do node free, which would free the symbol that we just copied. We do free, which just frees this node pointer, which has been allocated with node allocate. So the symbol is now transferred in ownership to type, and the node is now transferred in ownership to garbage. Nick says, okay, makes sense. And then we add the child to the type, which is now our function type. and we add our return type as a child to that type. How much you want to bet this exits with code 5? Ah, we didn't. Just still exited with code 1. That's pretty good. Oh, we forgot to do the closing paren. Look at us. That's actually, it worked. I'm surprised. Wow. Wow. So we'd like to prep an error, which is an error syntax, and this is going to say function type. What is this? Function signature type requires, I don't know. We're going to say expected closing paren, that thing, at end of function signature type. I don't think that's a great error message, but again, we're going to go through and redo all of the errors everywhere at one time, so we have that to look forward to. And look at us, expected closing paren. Because we expected an open paren. I was like, wait, what? Type function could not get type info from type's environment. Interesting. Where does that happen? That happens all the way in code gen. Okay, what's happening? We have a variable declaration of foo. Also, there is a function in the types environment, so I'm a little confused by the message there, but it's fine. Nick says ish. Yeah. Yeah. Oh, we don't need another expected. We can use the same one. So we have a foo, which is a function, which returns an integer. Hey, that's not too bad. So now, all we have to do is, I guess we have a choice here in parse type. It seems like we have to parse the parameters manually and not as variable declarations, which is big sad. That's actually big sad. Because that was a great part of what we did before. That's a big sad. Because I don't think there's any way we could have this be... So in a variable declaration, here, when we parse the type, see, we just use parse type, and then we bind everything and do it all. Oh no, this is just checking for redefinition, which is pretty pog to do in the parser. But effectively, Negvorsa says, hi everyone. Hey Negvorsa, how's it going? It's so good to see you. Thank you for tuning in. You're so good at catching my bugs. So after a type annotation operator, ensure it's not a reassignment, and then advance the Lexer and parse a type. I don't think that's too insane, but the problem is with a function type, we kind of have to parse more things. I think it's fine. Yeah, I think it's fine. I think we're just going to use a loop up here and parse parameters of function signature. Sure. So what we would like to do, sure, is basically advance the Lexer and save the symbol. That's, I think, all we would like to do. There should be a Lex advanced little ditty here. And this is the wrong error message. We're going to say length equals 0. I don't even know what to do about this. I hope we never see this error. We're going to fix this, I promise, but we're going to look at this. So we advance the Lexer, and assuming that we have something, which is what these try to ensure, sure, then we should save this something into a symbol. And I think we can do that. So we would like to say this is our parameter name. And this is equal to what? What is this equal to? This should be equal to a new symbol. And this should be probably from buffer. That way we can do current beginning, and then current end minus current beginning. And that will get us the string of the current token. I like that. I like that. I really should have node symbol from token, but yeah, it doesn't matter. This works fine. So now hopefully we get a parameter name. We're going to steal our little expectorino, expect a type annotation, and error if not found. Expected type annotation operator and valid type. We'll say expected type annotation operator following parameter name. A function. Sure. Sure. Errory. It's not an error, it's an errory. Wow. So after we expect this little type annotation, then we would like to, here's the kicker, parse a type. I know, I'm sorry. No continuations here. And yes, we're going to have to do this in a loop, I understand. We'll get there. We're going to have a new node, which is parameter type. And we're going to have current, length, and error. Wow. Okay. So effectively, we look for an open paren. We change our ideas of what the type is. We go, okay, it's not just whatever we've got. Whatever we got is a return value to a function. Looks pretty good, looks pretty good. And then we keep parsing parameters, I guess a single parameter. So we should do like while, I don't even know what to do here. It's gonna be rough. You might just want to do a forever and a break. That might be easier than having to deal with anything right now. But we'll figure it out. Because we want to say, until we find this. Which is a little rough. So we advance the Lexer, we use that as a parameter name. We expect a type annotation operator. We try and parse the type. Again, this should be a continuation. But continuation within a continuation is so mind-boggling right now. So I'm not going to worry about that. And we're going to use recursion and hope that you guys don't make infinitely recursed function parameters, and we'll be good. No stack overflows. In any case, after we get our parameter type, what do we normally do? Don't we have to like add it as a child to the function? So with finished parameter, add as child to function, or add to function context, or something like that. This is how we would normally do it, which may break at the moment, because this is just a type signature. This is not an actual function that we are parsing that has a body. We're going to do that in the Lambda parsing. So we don't need to do that. We just need to add this finished parameter type. I don't think we even need the parameter name, to be honest. But we need the type, and it's past the parameter, and then it needs a name, so again, we'll get there. Maybe eventually we'll allow having no name and just allowing straight types. That would be crazy. So you could say like, let's think about that. That means you could say, instead of bar integer and integer, you could just say integer, integer. And that would be a function that returns an integer when called and takes in one argument, which is an integer. Because this will never need a name. This is just a signature. Okay, so let's put that here then. And we'll say parse parameter name to do. Maybe make names optional in function signature. Sure. Looks good. Sure. Looks good to me. And then this is pretty self-explanatory. Parse the parameter type. And then we would like to add a child. I think just our parameter type to our type like that. Let's just think about how this works and not think about how that works. And hope that we don't die. Invalid syntax, expected type annotation operator following parameter name of function. Parameter name of function is a little confusing. So we're on foo integer. I see. I get the issue now. So effectively, we're going to just start a forever loop, and we're going to put everything that we just wrote in that forever loop. We're going to move the expecting of the close paren to the top. And I think we're done. So now, else, also we can't do this. We should say if found. So this would be if done. And then this would be else if expected.found. I don't really need the else because it returns, so we can just do this. So if expected found, then we'd like to break because we're done with the parameter list. Pretty good. We get type is not found in environment, which is, it makes sense. Is that during code gen? That is not during code gen. That is during parsing. And we have type not found. What? Do we have to advance the Lexer for parse type? I think we do. Parse type needs an advanced Lexer. So we're going to advance that Lexer for that parameter type before we parse it. Okay. I hope we never see this error. So expected type following type annotation operator in for function parameter. I don't even know at this point. Sure. Type function. Hey, we're in code gen. We made it through parsing. We have two variable declarations. And you can see that bar is a function with two integer children. So let's try and make it a little more complicated. Bar returns a pointer to an integer. What do we get? We now get bar. It's still just symbol integer. We should really print out the the pointer in direction amount, shouldn't we? Yeah, that's gonna kind of be needed, at least for right now. So I don't even know where is it. Print node. Where is it defined? So effectively, we use node text. And the idea is, okay, when it's a symbol, show its pointer and direction amount. And just like in here. I don't remember what it actually is. It's a node, it's an unsigned int. So that would be, that doesn't look right. I don't think this is how I do it. Does anybody remember an unsigned int? I don't. Do a little cleanup here. What do we get? Okay. It did not work. We get 0. Why do we get 0? So in node copy, I bet you we don't copy the amount, the pointer and direction amount. Yeah. That would be important. That's making more sense now. And this is why we do these things. Now look. So now, for our downwards funarg problem, we're beginning to make some progress. We're parsing the correct thing. We have a variable declaration of a symbol foo, which is not a pointer. And this symbol foo is a function. That's perfect. And it returns an integer that has no pointer in direction. That's perfect. Then we have bar, which is a function, which is exactly what we want, which returns a pointer to an integer. So it's an integer with one level of pointer in direction. And if we put 2 here, I bet you we'll see a big old 2 there. Look at that. So a doubly indirected pointer would be represented like that. And then it has an integer parameter type. That's not too bad. That's not too bad at all. Okay, so the idea now would be that we could take another one of these and assign it to bar. And it says could not get type info and code gen still. So type checking, it looks like this passed, but if this is a pointer to an integer, what happens? We're not type checking properly, right? It's quite clear that it's not working. So ideally, we should have something like this work in the type checker. But I don't know if we should start working on that before we start parsing of lambdas. Maybe we should do all the parsing at once. Let's do it. So let's work on a lambda. We'll put this to do here. This isn't type checked properly. And what is this? Function signatures. Okay. RPWH says, hi, Negvorsa. That may have been a 10-minute gap. Maybe I just have a delay in my chat, but that was amazing. Nick says, aren't isn't. Ooh. Thank you. Lamau. Nick, you're the best. We are doing good. Negvorsa says, hi, RPWH. Hey. We're all one big happy family. So a lambda. A lambda is going to be an integer which has a thing, a parameter with a name, and a body. And this is a lambda. And we can call it. Okay. Okay. Right? Nick says, I like how you used parenthesis for comments, because when you comment out a function, it winks at you, lol. That's true, it makes a sad face. A sad winky face, oh no. That's so good, the sad winky face. That's pretty good. But you're right. Everywhere, it's so sad. I wish I was a happy winky face. I wonder if it would be terrible to have some sort of Unicode character that like comments out the next character. So you could have something like here, and this would still be in the code, but everything past it would be commented out. I don't know why that'd be useful. That's cursed syntax, but it just came into my head. Says unknown symbol. We get all the way to we get all the way to here. So it thinks this is a function call, I presume. Yes, with a variable declaration n within it. Okay. Not quite right. Not quite right, but it's nearly there. Maybe a number 2 syntax would comment the next 2 chars, even though that's more cursed. Oh god. Yes. That'd be crazy. Just have the most complicated comment syntax in all of programming languages. Let's head into the parser and think about what happens. We parse. You would think that we'd get an unknown symbol, but where do we get function call? So if it's a function call or a Lambda declaration, okay? So we look ahead for this and we say, okay, it may be a function call, but this is only if the symbol is truthfully unknown. No, that means it can only be a function call if the symbol is known as a variable. Interesting, so this is going to break, because what's happening up here, I promise. See, we get a variable, and if there's a variable, we say, okay, it's a variable access. Then we look ahead for a variable reassignment after a variable access. So here is where we're going to have to look ahead for function call as well. So that's a to-do. We need to do that because if we get a variable binding, then that means that our function has been declared. And because functions are now variables, then that means that when we look up this symbol, bar, we will get it as a variable access of bar. And that's perfect. This is perfect. Nick says also, where's the multi-line lens? Yeah, it's just, I'm too lazy to implement it in the Lexer. It's too much work. But we can do it. We can do it one day. Eternal Wild Fox says, victory! Check Discord. Ooh, I'm curious. I'm curious. Yeah! What do we got? What do we got? Ooh, make it big. What do we got? We have an initialization statement, int a equals 1337, of the number expression 1337. We have an if statement, condition Boolean expression, nice, with the left 1337. Did you replace the value of this variable? Is this immutable? Is this a constant? In any case, then you do greater than 1336. That's perfect. Statement's print statement. Awesome. And expression number expression 1337. Nice. Oh, this is probably the already interpreted tree. So you went through and interpreted all the values. That makes sense now to get the answer. Because it was, you already have the constants. That's very cool. That's very cool, Eternal Wild Fox. And you did this with your new like parse rules. I saw that was, you were talking about that earlier. That's so cool. If we can ever find it. Here it is. All the parse rules. So you have like a token type, which is mapped to a parse rule. So an integer is a number and has like, this is so cool. I've never seen this type of parsing, but it's, I really like it. You have all your functions like defined in one little place. It's not spread out all over the place like mine is. It's beautiful. That's really cool, Eternal Wild Fox. Absolutely yay. Party. Woohoo. Nick says, perhaps, mayhaps, not perhaps, mayhaps, should comment everything until the next : Maybe. I was thinking about hash. We already support hash as a comment, but we already support semicolon as a comment. So instead of supporting both, I was thinking like maybe hash goes to the next hash. But I don't know. We'll see how it goes. So to do look ahead for function call, and to done is this can never be a function call. Check if it's a Lambda declaration. Because if we get to this else, that means we got to this else, and the symbol is not a valid variable name, which means it's not a function, so it can't be a function call. It must be a variable declaration. How beautiful is that? In any case, we have to check if it's a Lambda declaration. So what we'd like to do is say, this makes it a function. Also, function is now Lambda. Nick says, no, why would you support both? Both would be idiomatic, and I hate the inconsistency. It's not inconsistency to support more than one thing, or to have multiple ways to do one thing. That's called not putting all your eggs in one basket. That's like adding the Windows style and Unix style new lines for no reasons again. I mean, you need one style. Why not use both? Put CRLFLF. Perfect. No, that'd be double new line on Unix. CRLF is usually supported by most things. In any case, we have an argument list of our function, and we parse into that. Unless it's nothing. Done parsing lambda. So we should just say if found. We should ideally say if expected.done, like error. Expected thing. So we expected, closing parenthesis, blah, following lambda declaration, lambda argument list. Sure. Sure. Okie dokie. Oh, then return the error. Alrighty, and if we found it, then we're done parsing the lambda. And this looks ahead for a binary infix operator. I don't think we need to do that after a lambda. Does anybody else? I don't think we need to do that. But then again, what do we need to do? Parsed function call, check for stack continuation break, because that'll get us down here. I'm confused. We parse a binary infix operator instead of just breaking and parsing a binary infix operator. What is this cursed code? Just break. I don't think it matters what we parsed. Because then we go to the end of this while. This while. Oh, I see. There's the issue. We can't break out of the while because the while doesn't end here. Is that correct? Yeah, that's correct. So, again, we would need a go to. Okay, I see why it's here now. I see. It was my mistake. So when we're done parsing a lambda, I don't think we want to parse a binary infix operator. That's definitely not okay. Looking at the code, it was like, I wonder if this would be okay. And then you go to write, like, what would that look like? That's what that would look like. That's definitely not okay. So, and it's definitely not needed. We're just done parsing the lambda. Are we in a while? We're not in a while. How do we ever parse the argument list? What am I doing? This is an empty argument list. Nick says, no, I just got snacks. Do not add on to functions like that, please. With the not like this. Lamau. Yeah, that would be horrible. It would be here. Lamau. We're not done parsing lambda. Now parse lambda body. Body! Yoink. Otherwise, we're gonna have to say, hey, lambda args. Should I do lambda signature? We'll do lambda arguments. We'll do lambda params. That's fun to say. Lambda parameters. Perfect. And the idea would be that, yeah. Okay, this makes sense. This makes sense. Also, I've been streaming almost exactly 1 hour. I would just like to say, if you are interested, check out the Discord down below in the Twitch About section. We have code review, we talk about each other. This RPWH, one of our contributors, is making a custom keyboard and lubing all his own switches, which is so much work and amazing to see. Very cool. Also, I think we have the same mouse. Is that the G403? I think we have the same mouse. RPWH. I just realized. I'm like, wait, that's my mouse. And it's very cool. The Discord's awesome. I recommend checking it out. RPWH says Lambda parameters. That's right. Lambda parameters. Yeah, just pop these. Perfect. Lambda parameters. RPWH says 703, I think. Oof. Oof, you gotta flex on me like that, don't you? No, it's my mouse is like 8 years old. Eternal Wild Fox says, I'm pretty sure I can convert my code to support bytecode pretty fast, I guess. That's awesome. You're gonna have a bytecode compiler as well as an interpreter. That's pretty sweet. And then you're gonna need a bytecode interpreter. Lambda parameters. I really like that. So create a parsing stack with lambda parameters operator, and then start parsing lambda argument expressions. Perfect. So the result is our working result. Should I set stack body? I mean, why not? So stack body, we're going to set to our lambda itself. What have we called it? What have we called it? I mean, it's just symbol. So we have working result. What have we done? I don't think this is needed. Because we have working result, which is a function, and it just should have an argument list. This is a lambda, so it has no name. Also, yeah, that's going to be an issue, but we'll get there. This is a lambda, so it has no name. So the symbol is actually a type symbol. So we do need to add the child. Oh, interesting, interesting, interesting. Okay, so this is wrong. This is wrong. Gotta love it. Because here's the issue. Here is the issue. Man, this is a complicated one. Here it is. So when we parse an at, we assume it's a dereference. We continue to parse into the child of the at. It's a unary operator, and it's very simple. So the problem is if we put add integer here, this is going to be a dereference of an integer. That's how that's going to be parsed. I mean, if we wrapped it in brackets or something like that, it would work. But I don't think I want to do that. So we basically have to check for a type first. So, yeah. We have to check for a lambda first. Because it may be a lambda, or it may be anything else that's an unknown symbol, because this is not an unknown symbol. We only want to start doing string compares on a symbol if we think the symbol might be unknown. Okay. So we parsed an integer. Check for lambda declaration. I'm just going to say check for lambda. I don't know if this is right. Eternal Wild Fox, that is really cool to hear that you're going to be able to get your bytecode up and running. I'm excited to see it. I'm excited to see it. You do so much, by the way. You get so much done so fast. Like, weren't you working on a chip 8 assembler and disassembler like a week ago? This is incredible how much you've done. It's very cool. Also, RPWH, I was just messing about the mouse thing. Don't worry. I don't actually feel bad. It's just a mouse. But your mouse is probably pretty dope because it's a lot like mine. It's light and it works. That's all that matters. Yeah, we need to check for a lambda first. Otherwise, it's like totally not cool, dude. So we may just want to remove all this function call code. I know we just did a little bit of work on it, but I think it may not be worth it. We don't know what it is, is what this means. Okay. RPWH says, yay, all good. I like it a lot. That's awesome. That's really good. Eternal Wildfox says 2 weeks ago now, almost, I believe. That's crazy. It's been 2 weeks. Time flies by. What do we pass to parse type? Context. Current token. Token length. End. And the type that we would like to parse into. Do we have type? I think we can write type. Yeah, type is not an issue. So type is equal to node allocate, or allocate, as the big boys say. Take the address of what we need to take the address of. Handle our errors. Make sure those bubble up. And as far as that goes, so I guess we need to say what happens in parse type if we don't get a type. We're just going to create a symbol and then we'll return invalid type. So we return invalid type if it's an invalid type. Otherwise, we may return error syntax if it's not written correctly. So if there's an error, we didn't parse a type. And if there's not an error, we parsed the type. That's kind of all we got. Cool. So if error.type equals error none. Negvorsa says, isn't lambda should be as right-hand side or as function argument or as inline call, but never alone? I mean, in C, you can write like 5 and 4 and 2 plus 2. They're just unused results. See what I mean? Everything still works. I think it's fine. So having a lambda that isn't used, it's kind of helpful as you're writing code as well. You can be like, okay, I want a lambda which is an integer, and it takes in nothing, and it just, let's have it return 5 right now. And having this syntax work, and then you go, okay, I actually want this to be foo, which is an integer, and then that is assigned to that. And then eventually, all you're going to have to write is foo, right? So I'd say it's fine. But Negvorsa, you are absolutely correct. It's not going to be useful in any case like this, but I'm just kind of mimicking C, where it's fine to put it anywhere. We may eventually type check more semantics and ensure that it is like used in only certain scenarios, but in parsing, we're just going to parse lambdas as an expression and just deal with them like that. And even in code gen, we could say if a lambda is encountered when it's not part of something, just don't code gen it. You know what I mean? But you're correct. They do nothing, but we are allowing it. So if we do find a type, then this is a lambda. So then we need to expect an open paren like we did before. And effectively, if we don't find it, then we're going to say, we don't really understand what a type is doing there. Negvorsa says, okay, I get it. Awesome. Awesome, awesome. So if we just encounter a type, there's literally, we don't know what that could be other than a function declaration, a lambda. Because just a type, we never see type first. So seeing type first lets us know it's a lambda. And we can say, okay, if it's not a lambda, nothing except a lambda as, we'll say, starts with a type annotation. Sure. Sure. Error prep, error syntax, expected opening parenthesis, we'll say expected function parameters, parameter declarations following lambda type. I don't know. Sure. That's a terrible error. We're gonna have to fix all these, I know. So assuming that the open paren was found, we would like to sort of enter a new stat frame. Enter new parsing stack to handle lambda parameters. Look at us, we're back at lambda parameters. So let's look at another stat continuation and copy it, because I think that's the easiest thing to do. Right? Working result equals something, continue. So we're basically going to create lambda parameters. We'll write it out here, just so in case somebody's confused by this, they have a comment to look at. Alrighty, alright. Now, the stack result is actually going to be the argument list of the lambda. So currently, our working result isn't set up at all. So we're basically going to say working result type is a node type function. And then we're going to say node pointer parameters is another node. And this we're going to add as a child to our working result. And we're going to use that as our new working result. Actually, we're going to have first parameter as our working result. So I'm going to need to do this again. Can I? Oh, that's so cool. Emacs is so awesome. I don't know if you just saw that, but I switched the order of the parameters to the function with one keystroke. That was incredible. I was like, oh, I need that on the other side. Yoink. You can just do it. Oh, that's so good. That's so good. Expected parameter declarations following lambda return type. Where are we at? So we look for, interesting. Do we need to advance the Lexer? Does this not advance the Lexer? Eternal Wild Fox says, next up while statement after some coffee. Ooh, you're making so much progress. That's awesome. Negvorsis says, when you consider the instruction is terminated if you do not have something like C semicolon. Well, they're just different expressions. I'm not sure what you mean. Because like A is equal to 5. You're never going to write plus 5 here. You know what I mean? You're going to write B. So if we encounter a symbol, we know that, okay, there's nothing to look ahead. It's not the next thing. So we just use look ahead. RPWH says, geez, what's in the coffee? It's true, Eternal Wild Fox gets so much done. He's like, oh yeah, I did an if statement this morning. Time to drink some coffee and do a while statement. Like, two of the most complicated things you can do in a language. So awesome. But Negvorsa, basically by looking ahead. Because a 5, the expression will only ever continue if there's a plus or a minus or a slash or a greater than, if there's a binary operator. So after looking at 5, just look ahead for a binary infix operator, then you can go, hey, this expression continues. And if there's not one, it doesn't continue. Or if there's a function called and you know, okay, then we need to make sure this is a symbol and blah, blah, blah. Stuff like that. Why is this happening? Invalid syntax reassignment of undeclared variable is not allowed. Oh, my bad. So let's just make sure everything works. Yep, up until code gen, which is why we fail with code 3. But with the Lambda, we fail at code 1, which is parsing. So our little issue, type not found foo and type not found bar. Those are interesting. Those are interesting. Oh, so that's here in when we parse type at the beginning here. When they're not found, it's saying, hey, we didn't find foo, we didn't find bar, but we do find those as top level expressions. So at integer, is it a white space issue? It's not. We just say invalid syntax, expected parameter declarations. We're trying to get to a mishandling of the stack operator because this doesn't exist. So we're stopping here unexpectedly. So if we don't find an open paren, next, so maybe our current token is an open paren and we have to like, okay, let's think about it. Whoops. Why? Close paren. Now that's incredible. Oh, chat. I'm dumb. I am very dumb. And parameters of a lambda, turns out, are going to be handled in the type. Because that's now a function type with parameters. Ah. That's annoying, huh? That's very annoying. So, all we have to do is parse this. We just have to parse the body. There's no lambda parameters, guys. There's no lambda parameters. What do we do? So we're gonna have to know the names of the... Okay, we're gonna have a slight issue here, where we have to do like double parsing. So we may not be able to use parse type in the way that we are using it. Because we're gonna need the name, is our little issue. You know what I mean? We're gonna need the names of all of the parameters so that we can bind them in the Lambda environment, in the Lambda context. Oh, it's Gigabrain time. It's Chad time. If anybody has a Gigabrain idea, it would be great. Just solve this little issue. So when we parse a type, we're trying to parse the return type of this lambda, but we also need this. We need this name, because then we need to say, oh, in this lambda, it has a parameter named n, and it's a variable which is of this type. It's almost like we need to do like integer, and then like n, and name them this way, which is just horrible syntax, but that would be great to parse, wouldn't it? So, oh god, all the white space. RPWH says small brain reporting for duty. Maybe with all of our small brains put together, we can make a gigabrain, a giga chad. Okay. Yes. Things happen. Apes together strong. Woo woo. Yeet. We'll get them. So we're still getting this closing paren. So we need to advance. And we need to not deal with this. So to do, we need the names of the parameters, but we also need the return type of the lambda. How fun. In either case, we're just going to continue without thinking about it. And I know it's not going to work. It's fine. We're going to have body, Bobby. Why are you mad? Oh, because that doesn't exist. And this should be stack body equals body. I think that's fine. And this is going to be lambda body. Lambdati. Lambody. That's pretty good. We'll do it. We still need to do this. And create a context. And have context equal that. And to do, find parameters as variables in context. Woohoo! We did it. Or we should just have the lambda context as a part of the lambda. We'll think about it. Could not handle stack operator. Hey, we're here now. So now we can go handle another stack operator. I think we continue. No, we return something. Yeah. So we would like lambda body. And we'd basically like to expect a closing paren, really. A closing brace, I should say. Because that would allow yeah. Because this closing brace will allow for the lambda body to conclude when it is found. So this means that we are done. Eat lambda context or whatever. Perfect. So after eating the lambda context, blah, 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 then do we need to first check for else? We probably do. We need to handle the stack as well. So let's think about handling the stack of a lambda body. Stack is handled. We're done parsing. So all we have to do is say our stack is equal to what? Stack parent? It'd be the same thing. Yep, looks about right. And then we just have to set our status. And this is going to be a stack status. What is it? Stack handled. So stack handled and check for further stacks because we may have ended a lambda body and then immediately end another lambda body. So we want to make sure if there's another stack, handle that bad boy. Don't just give up. Also, Negvorsa with the apes in the chat is pretty legendary. The ape emojis or monkey. So the stack is handled. Otherwise, there's another expression in the body, is all that we've done. So another expression in the body, we do like, how do we do like? We do like next expr. Okay, I'm getting it now. I remember now. So with the next expression, we set the stack results next child to the next expression. So the stack result, assuming it has a parent, we set the next child of the parent to the next expression. We set the stack result to next expression, so that next time around we further the list, right? And then we say working result is next expression, because that's where we want to parse into. Then we say the stack is handled, parse me a condition, parse me an expression, please. Code 5? Code 5! Wonderful, everybody. We did it. How'd that happen? So our lambda body is 5. So we should parse an integer into the first expression, then find this. And then we should say context is equal to parent, stack is equal to parent, status is equal to check, return OK. I mean, that all looks just fine. That's kind of what we do everywhere. So it's very interesting that this didn't work out. Right? Also, yes, I know we have to handle empty as well. Why did we exit with code 5? Anybody think they know? Let's just try not doing the stack thing. Still exit. Not doing the context thing. Still exit. Okay. So we're going to have to break out the debugger because I don't know what the hell's going on. Unless you do. But it seems like when we now exit this context and then check, for some reason it's not going well. I'm going to open our favorite thing, the debugger. This little bugger. We got to feed it a new file, which is the downwards funarg. And try and run it. And tell us, magical C exceptions. Tell us your ways. Perfect. Type checking a function, we try and get the body as something that just totally doesn't exist. Perfect. Look at us. So let's also want to copy this. So we could just do something like this, but I don't think I want to do it that way. I want to just not have the stack created or handled at all. We basically want to say this is an empty thing. So what do we do in the case that we're just done parsing? Right, that's kind of an issue we have. We can't just be done parsing because we need to go, we would have to use a goto. So we'll say, if not found, do this thing. Otherwise, fall through here and hope that we can put an else on this bad boy. This is a big else. Oh my Christ. Big else. So I think it's here. That may not be right. So we have if parse integer, do this thing. If you parse a type and actually get one, it's a lambda. Also, this is current token length. Gnarly Quack says some else's are bigger than others, I guess. Lol. It's true. It was a big else. And if we find this, it's a lambda. But if we don't find this, not a lambda, else we'd like to do all this stuff. And all this stuff is checking what the symbol is. And this is at indent of 8. So when do we get past the indent of 8? Here. So this currently goes to that else. Else it's an unknown symbol. Why do we free var binding here? What is var binding doing? Else. Okay, it's in the right spot because there's an if else and we probably use it in both places. There you go. Free the var binding. Okay, so now lambda body should be dealt with properly because if there is a... Yeah, basically, if we find one of these, we'll just fall through and handle the current stack. Otherwise, we'll create a new one if there's not just an empty body. Still exit with code 5 because we still do the same thing to functions in the type checker. And if we print node of the expression we are type checking, I think we'll learn a lot. Yeah. So that's not much of a lambda, I don't feel like. I feel like a lambda should not just be a body of a function. I don't feel like that's what a lambda really encapsulates. So let's think about how we can do this in a less stupid way. Right? Okay, so this may be just as stupid, so no promises. So we're gonna save the current token and the token length or whatever. Also, why is token length a separate thing and not just part of token? What is wrong with me? Oh my god. In any case, we're gonna have token, we're gonna have length. Eternal Wildfox says while statement up and running. Are you serious? What? So while a is greater than 0, a equals a minus 1, print a. Oh boy. So it's a while statement with a condition which is 10 greater than 1. Is that right? No, that's the line number. My bad. 10 greater than a number expression of 0. So you replaced a with its value again, I see, which is going to cause some problems when you try and reassign it, right? But then you have a reinitialization statement of the number 10 and minus 1. So that will always equal 9. And then you have a write the number expression 1. With, again, that one I think just confused me. But yeah, 10 minus 1. And then a print statement of print a, which is just going to print 10 minus 1. Okay. I see what you're doing. It's starting. You're starting to get it. But you're building a tree. Hopefully... I like that you've started to print it out a little bit better. But it's still got some work to do. Because you need to print each child on a new line. Otherwise, it's very hard to look at, right? I didn't know the mouse worked like that there. So am I still, like, debugging? No, it stopped. Okay. Okay, that's very cool, Eternal Wild Fox. You are doing it. It is happening. You are creating a language out of nothing. Ooh, okay. So when we check for a lambda, turns out we cannot parse for a type. Parse for a type. I am not the smartest. And effectively, we need to like parse the base type. So maybe we need to split parse type up. Like maybe this type should be split from the function stuff, and we can like parse a base type. and then parse a function from that. But we do want a type of a variable to accept a function signature. So parse type still needs to be like this. But maybe we can do something like have this in a little helper. Oh boy. Again, I did that wrong. I'm good at doing things wrong. Okay. A little bit of copy and paste. Never hurt everybody. Except for when it does, right? That hurts everybody. Oh god, I'm scared. Okay, so we now have this function, which parses a base type, which is just a symbol with pointer and direction amount. And we can now use that, say parse base type. We'll bubble the error and basically say context, current, length, end, type. And effectively, Eternal Wild Fact says, oh, first time chat from a new viewer. How's it going? Resticinus. Cool name. A professor failed me for copy and paste. Well, they were probably correct. You really shouldn't copy and paste ever. But this case is just not copy and paste. It's moving something. We replaced the functionality here and moved it here. But it is dangerous, but it's fine when we recreate the whole environment like that. So now we can parse a base type separate from a function signature. And that's exactly what we're going to have to do to look for a lambda. So now if we get one, we can say, okay, do the thing you did before. So let's just let's deal with that here. So we're going to have an open paren and a closed paren, and this is going to be if expected.found to do create body stack and context and everything. Eternal Wildfox says, what should be next functions? Anything you want. It would be cool to be able to define your own functions. Or you could have, I have a feeling functions are so much harder. They can be. If you just do functions like we did, they're not too hard at the beginning. If you just treat them as separate things. Like a function is only allowed on global scope and is created with a keyword and stuff like that. Just be really strict. Resticinus asks, is this the C language? Yes, this is. This is pure C with no third-party libraries. Nexovac almost missed your chat. Hello, Lens. I will AFK today. Alrighty. Hopefully you enjoy and really get that good enjoyment out of this AFK stream. Also, Resticinus, thank you so much for the follow. Very much appreciate it. Okay. Yeah. Do the lambda thing. Otherwise, right, if it's not found, we'll do an else. Well, this is going to continue, so we don't have to do an else. And effectively, what this does is we continue. We want to do, this is all lambda body stuff. So this really has to go in here, is what I'm realizing. And then this can go here. This is I know the control flow is backwards because we finish first with an empty list and it's confusing. But effectively, when we parse a base type, we want to parse parameters. If there are no parameters, we want to parse a lambda body, which also means we have to expect an open brace. And say expected lambda body following lambda signature. Good enough for me. And this is going to be an open brace to start the body. So you can see if we were in here and we had at, let's just say integer like this, you can see that this lambda, which returns an integer, has nothing here. So we don't need to create a stack continuation or any arguments at all. We can just skip right past and say, okay, we found a close, let's find that body and expect this. It'll work. Restassinus says, are you doing this in V? Great question. I'm doing this in Emacs, not V. I am not a modal editing boy. But I do like Emacs. Emacs is very great. So that is what I am using. Where are we at? So we can create a lambda body. So now we have to actually parse parameters if they exist. So we have to lex advance. Can we do a lex advance? Can we steal one? Lex advance? No? Here it is. We're just going to do one of those, a simple lex advance. I think we need to do this at least, because we've expected this, so our current token should be this. So we'd have to expect something again, but we don't want to expect something. We just want to say parameter name is equal to whatever is here. Or, you know what we should do? I'm mixing myself up again. We should just create a stack handler. Okay. So how about either way we create the context, because when parsing parameters, we want to parse the parameter declarations as variable declarations into the lambda context. I'm not sure if this is how this should work, though. I don't know. Yeah, let's just do manual parsing for now. We're just doing manual parsing. It's fine. We are going to need a context for the body, and the context is going to require... Man, this is so confusing. The context for the lambda is going to require the parameters that it has. So this is where we're... Okay, I see now. I see now. Okay. I know. I'm being silent, but I'm thinking. I'm sorry. So effectively, now that we can parse functions, we're trying to have a lambda as an expression, and lambda is going to need its return type, its parameter types, and its body, because we want the lambda to fully describe itself, and that's everything it has. It has a return type, it has arguments, and it has a body. Those are the three things that lambda has. Everything else isn't needed, but that means that a lambda couldn't access anything outside of itself, does it not? Because if we don't ever have any context, then we couldn't use a global variable. Well, we could use a global variable everywhere, but we couldn't use a local variable if we define a lambda in a function, which is going to be another lambda. So thinking about nested lambdas, we could have like an integer function which has a lambda that just returns like 69 or whatever. And we can call this lambda. I don't think it's ideal, but this syntax may work if we allow calling of lambdas. Because a lambda is just an expression which returns a value, and the value happens to be the pointer of the beginning of the body. So when we call it, then we jump to the beginning of the body. I think that all works out. That's not too insane. Not too insane. But if we were to have something here, like a is assigned to an integer 69, and then we have a variable access a, this creates a very interesting scenario. Because everything is in scope. But the lambda... Interesting. So the lambda can access something that's outside of its own scope. Can you ever have a reordering of lambdas? Is something I'm curious about. So if we just use the way that C works, which is what we are currently using, where you're parsing, right? And you encounter a function, or a lambda, or whatever. So you, or a scope, or a block, whatever you want to call it, right? You encounter something that means variables can't be accessed outside of it. And within this, it creates a new symbol table as the next child of the current. So if we have the global symbol table, let's say that there's nothing in it, right? Then the symbol table would gain a function, it would gain a child. Okay, so then we have our symbol table. And currently this would have like things on it, like any global variable declaration. So let's say foo and bar, right? So foo. Gnarly Quack replies to Restinisis and says, Emacs if nobody's answered you yet. Nice. Thank you. Thank you so much, Gnarly Quack. Foo, which is a function, which returns integer, blah, blah, blah. So type. And then it would have bar, and its type, blah, blah, blah. But then, well, truthfully, this would be the other way around, right? And then the symbol table would have child symbol tables, like symbol table child 1. Let's do 0 indexing, because we're programmers. Gnarly Quack says, I've been AFK, so I'm behind, lol. It is all good, all good. We appreciate any and all viewers, and a chat is always appreciated, as long as it's positive, like yours was. So with this child 0, we'd have stuff in foo. And then we'd have a child 1, which has stuff in bar. And the stuff in bar, if we think about it, would be what? Bar would have at integer and integer, right? So it'd be like, oh yeah, there's n, and it's an integer. Because in the scope of bar, this has that. So if we then created a lambda, I know, bear with me. I'm sorry I'm so slow going through all of this, but we will get there, folks. So I then created a lambda. Is that any different from creating a function? We would not do this little symbol table thing, because there's no symbol to access the lambda by. But we would create a new child. And then when generating the code, we would iterate through the code. We'd get to the function, and we'd iterate to the next child. And even when we call this, we're not going to have to know the context, because the context is only needed for the internal body to know what size and type and name all these symbols are. So, all in all, I think it'll work, because then we can create symbol table child 3, which would be for this lambda. It would, for example, have a, which is an integer, and then we would have symbol table child 3 child 0, and this would have nothing. Whoops, where'd we go? Because this lambda is nested within this lambda, and it has no variables in scope, no locals. So stuff in nested lambda. Then we'd create symbol table 4, which is like another lambda. It doesn't really matter. N, which is an integer, right? And then while code genning and type checking, we could simply do the same exact iteration that we did before, where we start with our symbol table, we see a function, and we go, okay, that's the first child. And that's the stuff in foo, that's the stuff in foo. So this first lambda, even though it doesn't have a name, this ordering will still make sense. Sorry I had to go through all that. Maybe everybody knew that, and I just was a little bit slow on that problem. But I was trying to make sure that nothing would get reordered or anything. Because if we have lambdas that are... Obviously this lambda couldn't be then returned from this function like it is right now, or like that, but it can be called within this function. So interestingly enough, we're going to have a lambda that's callable, but not returnable. And we're going to have a lambda... The reason we couldn't return it to solve the upwards funarg problem is that, first of all, this returns an integer. And also returning a function is going to be some funky syntax, right? Because we're going to parse a type, which is going to be a function. But then the function that we parse is just going to be the return type of another function. So we got some syntax thought to do there. I think it's just going to be like this, where you have an integer function, which is a function. I don't know if this is going to work. We'll have to think about how this is going to work, because we're going to have a function signature type. Yeah, I think this will work. And then we're going to have to parse another function. We may have to put them in order. I don't know. I gotta stop confusing myself and just start making progress. I'm sorry, everybody. So, I think in either case, let's think about what we're gonna have. So no matter what, if we get an open paren, we're gonna want to say, okay, that right there, Gnarly Quack says defunky syntax. Oh yeah. It's going to be parameters. It's going to be first parameter. Parameters. I can't type. Okay, so no matter what, we'd like working result to be a function with a child of parameters. We would also like the base type to be a child. So we're going to do this up here. And we're going to say node add child to working result type. And that looks like it'll work out. So now that we have the return type as a child, we would now like the parameters as a child. But we would only like the parameters, the first parameter as a child. We only want to do this if we don't get here, right? So it's a little bit like this. So no matter what, we add this parameters child to our working result, which is our lambda. We'll do something like this. A little less confusing, I think, using the proper name. So add the child to the lambda of parameters after the return type. And if we find no parameters, then just create basically another child for the body and parse into that bad boy the first expression. I think that's all fine. And here's the first parameter. And I'm just gonna, I don't know why I'm using my mouse so much. There we go. There we go. That's not an exit with code 5. We got an open paren and it says, we don't know what that is. Okay. Also, the lambda parameters are back. How beautiful is that? Could not handle stack operator. Cool. So we're effectively at lambda parameters now. Woohoo! Lambda parameters. So we would like to expect. I like the term lambda parameters, says King Buns. That's awesome. I'm happy you do. I do too. It's really funny. You can thank RPWH for that. He came up with it. Or they did, I should say. So I feel like we can just copy this bit here, and it's going to be exactly the same. So current, this is going to be just length. So it's going to be working result type. So it's going to be, let's see. We already set the type. We don't need to do that. We don't need to create a context. We need to do that either way when parsing the lambda parameters. Okay, let's think about this. Let's go back down. So down here, we don't actually have to set that, but we would like to create a body and add it as a child. We don't need to create a context because we would like to do that either way. Perfect. And with that, we will say, okay, we have a body, a first expression. So we don't need to create a new stack. We just need to enter a new stack. So we're going to eat the lambda parameter stack, and we're going to enter the lambda body stack. So we're going to just use the existing stack to not have to change everything. And then this just needs to be star working result. Neg Vorsa says, can you return a local lambda that takes parameters from its parent function? Nope, we are not doing closures. First time chat from a new viewer, Lico13 says, hello. How's it going, Lico? What is up? Hello to yourself. So we are parsing our lambda parameters, and we found the close, so we'd like to expect our opening brace and say, okay, there needs to be a body for our lambda. And we create the body, and enter the Lambda body stack. That all looks good to me. We need to set our status to stack handled, I believe parse, because we'd like to parse the first thing in the Lambda body. King Bun says, I ended up learning evil Emacs, not sure if I could do holy. Lamau. Lico13 says, doing good. I see you're making a compiler. For what language? This language. I made it up, and I am currently making it up. It's fun. But yeah, it's just this language. It's statically typed with declared types. There's minor type inference planned, but nothing major. And we're going to have lambdas, so nested functions allowed and everything. And we're currently solving the downwards funarg problem, where we want to pass functions as arguments to other functions. That's just a little update as to where we are. So now we're trying to parse lambdas as expressions. Okay. So next expression stuff, what I'm talking about here is we just need to parse another thing, which is done a lot. And this is just another parameter that we parse. Could not handle stack operator. Which one? Lambda parameters. Maybe I spelled it wrong. Which stack operator? Why don't you tell me? We're going to print the stack operator. And it's going to be something. Whoops. Oh god, what did I just do? There we go. Hello? Why? Oh, it's a node pointer, so we need to use its symbol. What do we get? Invalid stack operator, lambda parameters. It's not? It's right here? Hello? I mean, I can literally copy and paste and go back up. Okay, so maybe we don't return. Oh yeah, look at us. We're silly. We didn't return. Unknown symbol. A closing brace. Would you look at us? So in the lambda body, unknown symbol closing brace. How does that happen? What? Oh, it's okay. Is it an empty? Maybe it's an empty thing? I don't know. Lico says, that's cool. Awesome. I'm glad you like it, Lico. Do you use ASTs or just transform the syntax directly into IR? Those are kind of the same thing. Intermediate representation is anything in between the compiler and the executable, or the source code and the executable. So I would say I use both, but we use an AST as our intermediate representation versus a DAG or anything like that. So if I remove this, do we get the same error? We do. We get unknown symbol. We get type not found closing brace. So where are we not handling a closing brace? This seems very odd, right? Because we don't have any empty anything. So it would seem that... So we get a function, two variable declarations, then we get a function, which is an integer, returns an integer. It has a body of 5, and then it's not finishing. I'm kind of confused why this isn't working. Print token. Current. Excuse me? What do we get? I don't see it at all. Do you see it, chat? Should be pretty obvious now. So there's no here. We're not getting here, which is confusing. That's very confusing. So when we're handling a stack operator of lambda parameters, we enter lambda body. Liko says, oh, okay, I thought your output was some other intermediate representation. Didn't realize it was an AST. Well, currently our output, we just have one backend, and it's the x86-64 assembly. So that's our output, but then that gets compiled into an executable by GNU as an LD. Because we don't want to write an assembler and disassembler and linker and everything like that. At least not just yet. So, confusingly enough, so let's go down to where we deal with lambda body. I see. You see? We didn't continue. That's better. That is better. Where are we printing that node from? Why are we printing out the function, by the way? Not there. Ooh. So we now have 3 functions. Let's take a look at what we got. So we have function, which returns an integer, takes in no parameters, and has an integer 5 in its body. Look at that. We have a function, which returns an integer, which has no parameters, and has a variable declaration of a within its body, and a reassignment of a to 69. Because that's how we do our variable initializations. We just do a reassignment. Which, probably not the most efficient, but who cares? So if we had a nested function, I still am not sure. Do we exit 1 in the parser? We don't exit. Okay. So a little confused as to why we're exiting after just printing a single function. We'll have to figure that one out. But it doesn't matter. It looks like we've parsed quite a bit. And we even have nested functions. So you can see we have a function which returns an integer, has no parameters, and has a variable declaration of a, which equals 69. Then we have a function which returns an integer, which is right here, with a variable access of a. Very cool. And then we'd have to call this. Does that work? I don't think that'll work. We have invalid syntax, unknown symbol, blah. So ideally, when we parse a bare lambda, we should say look ahead for a function call and see if the lambda is being called right away. That may be something we want to do. Or we just don't allow calling a lambda right away, but that's no fun. Handle grouped expressions through parentheses. Yeah, we still need to do that. It's fine. Yes, so basically, when we're parsing the lambda body, after we find this, we'll have a to-do. Look ahead for immediate call. Funkaton. Function call. Perfect. Okay, so our AST, bunch of type not found, that's perfect. It's fine. And we can see that this function returns an integer with 1 level of pointer and direction, which is correct. And it has a variable declaration of n. which is then totally incorrect. What happened? So it seems as if something has went very wrong. So we have our parameter, and our first parameter gets parsed into here. Liko says, what does the at mean? That is a pointer. So in C, you would write an int pointer like that, some integer pointer. Whereas in this language, you would write it as some integer pointer with a type of a pointer to an integer. Negvorsa responds with pointer. That's perfect. That's exactly what it means. So here's C, and here's ours. There you go. That's the answer. So this add integer is referring to the return value of this lambda. The return type, not the return value, but it's fine. And also, I understand this isn't valid, because we're not type checking things properly, which is what I'd like to check eventually. So we have a function with parameters, so we have to go lambda parameters. And the idea is that, see, we use working result here, and we absolutely should not. This should be the stat result. Because the stack result is equal to what? See, even the stack result is wrong. I think I have to do star stack body next child equals body. Right? Something like that. Take a look. See, that's much better. So now our function has a variable declaration of n. We create all these, hopefully, scopes still, our contexts. How many functions do we have? 1, 2, 3. So we should have 3 child contexts. We have 1, we have 2, with the child one, and 3. I think that's valid. I think that's valid. So why are we printing this out? Like, what is the significance of this? Should I feel like I added something and I'm forgetting. Type checker maybe? Yeah, here it is. We finally made it to the type checker. Because I think we're parsing properly now. Da-da-da-da. Oh, my brain hurts. Okay, so I may need to take a small intermission. I've been streaming over 2 hours and my brain is fried. But I'm going to keep going for now, and we'll see how it goes. So with these variables, ideally we want to type check that they return the proper value, because this doesn't and this doesn't. Okay, we'll just move on to type checking. We're going to do it. We now have lambda expressions, and we now have types that are function types. So we have function here as a type. Negvorsa says, did I see exit 1 in type checker? You absolutely did. We are now here. So handling functions with an empty body should be as easy as basically wrapping it in an if. So we'll keep that there, but keep in mind it's not too difficult. So if we don't exit 1, we get mismatched types. Return type of last expression in function does not match function return type. Oh my god, chat, it worked. Chat, wait, what? So return type of last expression in function, int 5. Int 5, see, is not a pointer to an integer. So it's saying, hey, that's a big problem. So if we have just an integer, we still get the same error, which is a little worrying. And we say return type of last expression in function. So this is not working. So expression children next child is not our return. See, our return is our expression children. How crazy, I know. Return type of last expression in functions. Now variable access A. What? So maybe a function's return type is not being set properly. Yeah, this is looking a little rough. Oh man. Oh man, oh man. So we need to have this be the result type. We basically need to say it equals expression children, no? Because that's our return type. Yeah. So what's happening now? Could not get type info from types environment, type function. Huh. Could not get type function from types environment. That doesn't sound right, because the function is a type that's like all the way at the top. Also, this is from code gen, so we're making it all the way through type checking now, which is pretty baller. Except this is wrong. So this is a function integer. Okay, I'm starting to get it now. I don't think this is the right way to do this, but this is what we're doing. Again, very bad. Do not copy. This is horrible. Function. Could not get type info from types environment. Still, huh? Still, huh? So which type are we looking for? We're looking for type function. Why are we looking for type function? Why? So we have a function which has a function at the end of it. That's all completely valid. We have the symbol function, which is a valid type. It's a function type, and it's 8 bytes because it's a pointer. And again, that'll probably have to change, but it doesn't matter. Binary operators, functions. So we get through all 3 functions, it seems like, at type checking, which is confusing because this expression should return a function. So could I print out the last expression return type? A little marker for us. RPWH says, I'm back. Liko says, hold up, you're parsing, populating the symbol table, and type checking all in one pass? No. This is a type checker. It goes over the AST, which the parser generates, and the parser operates on the tokens, which the Lexer generates. It's just a nested thing. Because we have, like, source code, right? That gets fed into the Lexer, which turns it into tokens. And the tokens get fed into the parser, which turns it into an AST. And then that gets fed into the type checker, which just is the same AST. It's just validated. If there's errors, they'll be caught and returned. And it won't be code gen, which just produces code. Right? Ideally machine code, but currently we just do assembly code. So it's effectively just a different stage. We don't do it all in one pass, Liko. RPWH says, I'm back. I may have read that already, but welcome back, RPWH. It is so good to have you. And how are you doing on your switch, your lubes, your lube? How are you doing on lubing your switches? I can't speak anymore. So expression return type is integer, which is a little confusing. So interestingly enough, this has to be an expression return type of integer would have to be here. So why aren't we capturing this? Right? We should have symbol function, which has a child as an integer. See, we have here, this returns an integer. What does this function return? Well, it has a nested function, and this function returns an integer, because a is a variable, which is an integer. Totally valid. Then we get here, and we get symbol integer again, which is a little confusing. So we're going to say, can we save the last expression? We're gonna. Whoops, not sure what happened there. Perfect. Print me that bad boy out. Okay. So now we have a function which returns integer 5. Integer 5 returns an integer. Da-da. This function has a function at the end of it. So it says here, variable access. So this function ends with a variable access, which is an integer. Totally cool. Then we get here, and it ends with a function. And for some ungodly reason, it says symbol integer still as the return type. So when we type check a function, our result type is not being set. But it should be set right here. No? You see why I'm a little confused. So result type should be a node symbol of function. So this symbol should be function. You know what I'm saying? Because this is a function. A variable access of a makes sense. Oh, it's an integer. But a function, result type should not be integer. It should be a function which returns an integer. I'm not sure why this is not exactly happening. So what happens if we're just going to print out children? Also, yes, I know this is a mess. I'm sorry. I am sincerely sorry. RPWH says, I took a break, but only 15 left. Nice, you're getting there. That's so amazing. I still can't believe you did all of those by hand. So we have children, simple integer. So I'm not sure how we're returning it. This is a little annoying. It's fine though. Ah, chat. Chat. Oh my god. I figured it out. So we're trying to reassign a pointer, which won't update where the pointer points to. You dummy. A little better. A little better. Let's print out less things. Mismatch types. Return type of last expression in function does not match function return type. So we see function 5, function bleh, function this, but then this function says, hey, this is not correct. You're returning a function. RPWH says, gonna have another 58 to do when my Lily arrives. Oh no. No, no, no. Monka S. Lamau. I'm so sorry. RPWH. See, if all of my followers, we could just do one, it would finish them all for you. It would be a lot in shipping, but we could do it. Also, I missed 2 follows, a Dragomir and Liko13. Thank you so much for the follows. I very much appreciate it. And welcome to our epic compiler club. How about that? How about that? Okay. We could really print out some things and say expected type and like type of last expression, say return type. And we're going to print out the expected type. So now it says expected type, integer, return type is a function which returns an integer. No good. Also, I like that the return type has the function definition. I don't necessarily agree with that. So effectively, we're copying next child when we shouldn't. I know. Again, we need an arena allocator. So hopefully this won't copy the next child. See, that's better. It's a function which returns an integer versus an integer. And that is totally correct. And we're right back to code genning. Could not get type info from types environment with the type function, which is a little spooky because we absolutely should be able to do that. So now during type checking, I went a little too far. We definitely do that. We also need to type check the body in the proper context. I think we're doing that as well. So handle functions with empty body. Next child, next child. So we don't need to parse the body, but we do need to set the return val and everything. We also need to eat the context no matter what. So this needs to happen no matter what. This is the return type that needs to happen no matter what. This is the expected type of the last thing in the body, which if there's nothing in the body, there will not be anything. So that definitely should go in this. And then this is type check body of function. And this is only, we'll say only handle function body when it exists. Sounds pretty sane. And then free expression return type. Why would we do that down here? We'll do that here. Okay. So now in code gen we're having issues, but type checking, it's going rather well. If you return a function when you really shouldn't, it says, hey boss, no. And if you return the proper value, everything is fine. Cool. So with that, does this work, by the way? Yeah, that still works when it shouldn't, but it's fine. Still gotta type check function signatures during reassignments. I'm not sure why this doesn't work, but it doesn't work. Lander XT, sorry with the yawn. Lander XT says, just checking in the stream so I technically don't miss it today. Welcome, Lander. You did not miss it, you are here. Also, Nick says, I finished a little parser that does simple math and prints the result. It respects the order of operation and supports whitespace. I know it's not much, but it's my first language that isn't one-character instructions. That's very impressive. You should absolutely be proud. And it is a lot. It is much, Nick, I promise. Like, this is all really complicated programming issues, right? And you solved them. So I'd be proud. I'd be proud. Also, thank you for tuning in, Lander. I appreciate it so much. It's great to have you around, even if it's just for a quick drop-in. Okay. So, I would love to find out why this reassignment doesn't work, or doesn't type check. So, reassignment, we type check the left-hand side, we type check the right-hand side, and then we compare their types. Not sure how this is being misconstrued. Ah, see? We're not checking children. This is probably a good warning too. We're gonna say warning. Type compare symbol. Called on non-symbol nodes. We're just gonna have a little warning for ourselves. And then we can do this. So then we'll have node pointer a child equals a children, b child equals b children, oh boy. Liko says recursive compare. That's exactly what we're doing. So we have our children and we would like to compare each one. If it's 0, return that. Otherwise, set each one. Also, total mistake here. There we go. Set each one to the next child. And as soon as one of them is null, and they're not equal, that will happen. So they must be equal to return 1. Okay. This looks somewhat understandable. Why? What did we do wrong? So if A and B have unequal pointer and direction, I see, I did this wrong. Well, no. I mean, we could do it like this. I don't think this is should be different any semantically. Yeah, I don't think it's that. So we have A and B, which are nodes. Dereferencing them is fine because it is. If not A or not B, then we should like have a whole bad thing happen. Warning. Sure. Called with null args. Perfect. So we don't see any of these warnings. Just exits with code 253. We could even try an fprintf into standard error. That way it comes out. Nada. So the idea would be that, let's see, why doesn't this work? A, B, while A child and B child, so they cannot be null pointers. Type compare them. Right. And if they equal 0, like they're not equal, well then this type isn't equal, so bubble up that error. Otherwise, just assign it to the next child. This is interesting how we're getting such errors here. Liko says, it's cool to see you do this in C. Most compiler codebases I've seen are in OCaml. What compiler codebases are you looking at? So we need to compare every symbol. Exited with code 253. I've never even seen that before, so this is an interesting one. What happens if we just don't code gen? It's not during code gen. Liko says theorem provers. Oof. So like cock? RPWH says people use OCaml to bootstrap self-hosted compilers, or at least Rust did. I mean, you can use whatever language you want. They all are the same. They're all Turing complete. So, I still don't understand why this doesn't work. It doesn't occur to me why this would cause a problem at all. Like, not one bit. It's obviously that, though. Something in here. I gotta do that. Exited with code 253. Huh. We're gonna have to go to the grossest thing in the world. A debugger. Take us to your leader. Thank you. So it's not a symbol. Why is it not a symbol? What are we comparing? A and B. Has a type of 2. Type of 2. Has a value of function. And a value of function. So these are both function symbols. And when we look at its children, excuse me. If we look at its children, A, children, it has a child. B, children, it has a child. And it has an integer child. Looks pretty valid to me. And in the integer child, it has no children, has null children, but it does have next child set. So we have function, which points to an integer, but that has next child set on it for some reason. And next child is set to what? Another symbol, integer. So this is a function with 2 children, both of which are the symbol integer. And B Well, how did we get unhandled exception? Where are we at? Ooh, I think I figured out the issue. What happened? So we keep just saying if type compare symbol AB. Ah! Chat. I did it. This should be A child and B child. We just keep comparing A and B over and over. We did it. Hooray! Gotta love C. Anyway, now that we fixed our silly mistake, we're back into code gen, which sucks because we should have got this working and not being properly compared, but whatever. So when we compare these children, I'm confused as to how these are the same thing. So please tell me. Just curious, what gets printed out? We have symbol integer 2 and symbol integer 0. And it's the same. How is it the same? Because bar should not be at. Oh, it is at. That does work. Whoops. So now... Hey, okay, it was working the whole time. I'm just pretty dumb. Look at us. So now, with this bar being a pointer to an integer return value, you can see that the pointer and direction levels do not match, so these two functions have mismatched types. Pog! We're doing it. Function signatures are now type checked properly. Haha. Alright, this is some good progress, We still have the code gen thing. Cannot get type info from type's environment. Type function. So we're trying to do parse get type when we shouldn't. There's only one place ever where we parse get type, so I would assume it's here. I don't see it though. It doesn't look like it's here. Okay, so it's not here. It's not this parse get type. Could not get type info from type's environment. In what environment? Generating global variables. Yes. Okay, so we have an ID and a type. So this is like a key and a value pair. What? And the type ID oh Lord. What are we doing here? Oh Lord. The nested while loop is throwing me for a loop. What? Liko says, Pog, it's working. Yeah, Pog. Give me that Pog chant. Oh yeah. We can celebrate. It is working. We now have Lambda expressions that are being properly type checked with each other, and we can do like variable accesses on a function variable and have them type checked properly. We are so close to solving the downwards function argument problem. There's going to be a lot of code gen still, but I've already figured out how to solve it. We just have to figure out what this cryptic code does. So we have variables in this context, and we're iterating over them. So we have the name of the variable and the type of the variable. The type will always be a symbol, so I don't think we need to deal with that. I don't think this will ever happen. Gonna check. Yeah, everything's still fine. So I'm presuming that we have to check all contexts. So we have to do parse get type from context, like this, and say error equals if error.type return error. Well, what we're going to do is error prep actually and say could not get type info from types environment. Good enough. We'll print out the error that this returns, and then we'll return a new error that will then be printed out. Yeah, see? Type is not found in environment. Could not get type info from types environment. See, this would only be helpful as another error if we actually have a better better error message, right? So maybe we just return the same error, but we like print something out. Like, I don't know. Let's just, we already say type not found function. Type is not found in environment. It's kind of clear. We'll make it better in the future. In any case, we're going to get rid of that because it was just confusing everything. And we don't need to do this now. We just need to say that. We still say type not found. Why? Why do we say type not found? Is that here? I know. I just did this, but please bear with me. My brain is fried. See, we are here. So why aren't we getting this type ID? It's a function with 2 children. I see the issue. We don't care about the children at all. Like, at all. So, this is interesting. We only care about the children during type checking. During code gen, we just want to know what's the type, like the base type. Because if we look at parse get type, we can see that we say while context, get in the types environment the ID. And in environment get, I'm presuming we don't use a simple node compare. We compare all children as well. And that's probably worth it. So we just have to search by a different thing, that's all. So our type ID is actually going to be a copy. Whoops. It's going to be a copy, I guess, from var it value into type ID. But I only want to copy the 1. Okay, here's what I'm going to do. We're going to say type ID, but we don't want to dereference it. Well, we do. So we want to say it is equal to the var it value. And then this type ID, we can change the children to be null. And same with next child, even though I don't think that matters. Perfect. Perfect. Now just more code gen issues. But it seems like we did get the type, and if we look at code.s, the code we generated, hey look, it's beginning to look a lot like Christmas. We have L0, which is our first lambda, and you can see there's an integer 5, and that is what gets returned. In the main, we jump over the execution of this lambda right to here, where we jump after the execution of this second lambda. where we jumped after the execution of this lambda, which we didn't get through because we have a variable access A. What's our issue? So variable access of A, and it's saying cannot get offset. Variable access of A, and we cannot get the proper offset. Where is this error from? What are we seeing? Could not get. So we say environment get by variable. Oh Christ, what is all this? Okay, so we're gonna do an offset. And we're gonna say while context. See, we need to know the offset from the base pointer to this, or we'd have to generate code that like loads the base pointer off of the stack, and I really don't, we need to do this. Liko says, so there's no malloc in this code gen? No, absolutely not. There's nothing that you should need to malloc in the code gen, right? I think we do allocate like labels and stuff, but we do that through static memory. So we are going to need the stack offset of parent variables, but this we can't do yet. So effectively, there we go. Whoops. So now we have bar, bar, and foo, which are all global variables. So we have bar, and foo, all global variables. Very cool. And let's see, we don't actually do anything about this, do we? So we just declare these variables but never assign them. So again, not worry about pointer to integer or anything yet crazy like that. Let's try and get foo to actually be a thing. So we have a reassignment, which is this reassignment right here, this equals. And this foo function gets reassigned to this lambda. So we generate first the lambda on the left hand, as the reassignment expression. So the code generated for the lambda is here. So this is a function where we push the base pointer, move the stack pointer into the base pointer, make some stack space, push our scratch registers that we may want to use that are callee saved, or caller saved, I should say. Yeah, callee saved. Move your return value into your return register, and then get blop on out of there, right? And after that, oh, this is beautiful. We move racks into foo of rip. Nearly. Nearly. See, the problem, which I think we can find here, when I look at, what was it? .s. So I did some tests to try and get a variable that contains a function address and a function address that is able to be called from a register. So effectively, here, this is perfect. When a variable reassignment of a function happens, we must store the generated function start label in a register. So a function, see, this is the return value of a function expression, the pointer to the beginning of the function. So this label right here to the beginning of this foo function, right? It is actually a memory address, and we can load the memory address into a register using load effective address. you can see that this is not a move instruction. So what we're going to have to do is move, is like load the effective address of the function after the function after label, which means that we'll jump over it and then it will be an expression on the top level, a function, not when it's called, but just the function itself, the lambda, and it will generate, it will store its address in an expression, in a register. And once we do that, then we can do move, and we can have racks store our function address, right? And we can move that into this global variable, or into anywhere in memory. And then to call something like this, we can do a variable access on foo, which will move the reverse of this, right? And then we can call that address stored in racks with an indirect call. And that allows you to have a function address in assembly called as a function. So this is kind of what our expression needs to do. Our function expression during code gen needs to load its effective address into a result register. So during a function, also we will never have a name. So I don't think we need to worry about this. Because a function is just going to be a lambda, and the actual variable will just contain the label, which this contains. Very cool. Eternal Wild Fox says, winner, 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 chicken victory, lol. Check Discord. Functions working. What? Function test int I print I test 1. Oh, that's cool. You have a function statement which has statements. I presume this is parameters. Yep, param. And it has a keyword which is an integer and a name, which is I. Okay, I'm starting to get it. And then you have statements for the body, which is a print statement, which is a number expression value of 0. See, this should be like a variable access value of 0, but I see where you're getting at. And then function call statement, expression, number expression 1. That's very cool. So you can function call, you can make a function call statement. Yeah. So you defined a function and then can call it. That's so cool. Very cool, Eternal Wild Fox. Very cool. Thank you so much for sharing. That's awesome. We're gonna party. We're partying. Woo woo. Also, I went to the wrong place. That's really cool. Thank you so much for sharing your progress. I can't believe you did that so fast. You're moving much faster than I am in my little silly thing. Hey, look at this to-do. It's exactly correct. So we need to set our return, which means that we need to have a register. So our expression result register. So this expression is an expression, so it returns a value, and that value is in this register. Register allocate base. So with this register, we'd like to output code to load the effective address into whatever the name of this register is. What's the issue? Two foo arguments to function call. Oh, I need R. Passate the registers. What's your issue now? Data argument not used by format string. Hello? Do I need to do 3? I don't think that's how I do it. Just do %s. So maybe the percentage, yeah, the percentage is included in the register name. I get it now. I remember. I remember my own code that I wrote. Let's So we're going to load some address into that. And that would be... It seems like it would just be this. Okay, apparently it worked. So we have main. We have a variable reassignment, which should be foo or something. Foo. And a variable of foo, which is reassigned to a lambda, or a function, which is called L0. So this lambda has been called L0. Very cool. We push the base pointer, push our scratch. Again, we should optimize where we only do this if we need to, but doesn't matter. Integer 42. So we move 42 into racks, so that's this 42. And then we return. So when you call this label, or this address, we will execute all of this and then return. But at the top level in the main, we are just going to jump over this generated code to here, where we load the... I didn't do a new line. Guess what I found out. Okay, so we jump over to after L0, right? And after jumping here, you can see that we load the effective address of L0, the beginning of our function, into racks. We then move racks into foo, our global variable. So now foo has been reassigned to a function body. So now when we call foo, right? Invalid syntax, oh no. We can't do function calls. I forgot, because we have to look ahead for during a variable access. Remember that, chat? There's a to-do in here. Yeah. It's in here. We fixed this. I don't know if we did fix that, actually. I think we fixed that. Parse strings and other literal types. Parse lambdas, rip. We did that. Also, we should definitely get rid of this defun thing. Now that we have this other way of doing things, we don't want to have defun at all. Goodbye. Anyway, look ahead for function call. I finally found the to-do. We did it. We're here, chat. And basically, if expected.found, then this is a function call. And we don't want to have a variable reassignment as well as a function call. So I'm going to move this up a bit, is how this is going to work. And it's going within an else, folks. I really wish there was a more concise way to do control flow like this, but there is not. Because in C, you can't say like this or this. You know what I mean? It's just if else. I'm talking about like match statements, but it doesn't matter. So if expected found, this is a function call. To do. Ensure variable access is of proper type. Function. We don't need to do that here, but we can. There's no reason not to get the answer now, rather than later. So we then need to parse parameters. So this is going to be a stack operation. And we're basically going to create the fun call stack operator. And these are going to be the past arguments to the function we are calling. Alrighty. So working result is going to need to be copied. Eternal Wild Fox says BRB needs some tea. Pog. That's a great idea. Stay hydrated. Okay. It's a function call. And its value. How did we do function calls before? I don't remember. In any case, I'm just going to say value equals 0. I think that's fine. Okay, so now we would like to add a child to the working result. And this is our var access copy. So now our working result was a variable access. It is now a function call with the function name, the variable access, the function variable access as a child. So then we just need all the parameters, right? So then we're going to need to say working result params. And then we're going to have to add to do my little tricky poo. Guess not. Hello? Hey, no. There we go. Had to do it backwards. Cursor was in the wrong spot. So parameters, we want our first parameter, and then that's our stack result and our working result. And then we just go and create our first parameter. Oh, and also our parameters. And to do, we're definitely going to have to handle an empty case. So we're going to expect a close. And if that is found, that means it's empty. So we're basically just done with the function call. Ooh, that's rough. Real rough. God damn it. So if we fall through past this else, we're just going to free var binding and then go do this stuff. Or, yeah, we're just going to free var binding and go do that stuff. So this is a little confusing. We have a variable access. And we're trying to look ahead for a function call. And if it's a function call, we say, hey, this is a function call. Do the things. And currently, we should just find this. Which means we fall through and never do anything. We should just parse, because we fall past this else, we fall past this else. We fall to here, which is just another else, we just continue. And we should look for an infix operator, which makes sense, because if we have that, we want to parse it. And we're getting exited with code 5. We're going to have to use the terrible thing again. Our debugger. Value children was null putter. What? So function call. Okay, so during type checking of a function call, so one, we'll do that not in the parser, right? There's a to-do somewhere here. Okay, so now ensure variable that is being accessed is a function, is of function type. That's one to do. Major as well. Next, for the function call, we'd like to ensure that each argument matches the expected parameter. So, so we have the name of a function. We need to get its type info. Okay, still no. So value children. What is this? Expected parameter. Expected parameter should be, do we say like next child? We say next child, so expected parameter should be, I wish I could look at the AST. So value, when we create a function node, a function type, that will be here. So value children would be what the function, okay. Please exit. So we have function integer, like I was saying. We have a function node and an integer node. So the function as a child, which is the integer symbol. So we are going to first do this to do and say if type compare symbol. I don't think we need to do that. We just need to make sure that this equals 0. This is also horrible and will be refactored eventually, so I'm sorry. And we're just going to say, is this a function? And if it's not a function, we're going to return a type error. It's a type error, and we're going to say a called variable must have a function type. Sure, and we'll print the expression node just to do something. Also, I typed error type instead of error prep, which is pretty funny. Should be a little better. So if we call something that's not a function, we should know. And now we just need to say, I think like that. Not quite. Invalid arguments, not enough arguments passed to function. Expected argument, symbol integer. That's definitely incorrect. So this should equal null, which means we don't do anything. We say, if it does not equal null, there's a problem. So when there are no parameters, right? Only type check parameters when they exist. That's probably a good thing to do. So value children next child. If that's not null, then we have parameters to deal with, and we can do all this jack crap. So I think I copied one too many there, but we're at the bottom of the switch case, so it doesn't matter. Woohoo! Okay, Liko says, do you have multiple parameters in a lambda or just carrying? Currying? I think carrying. We definitely have multiple parameters in a lambda. We're getting there. That's why we do a while and check over each parameter. Hey, look, it generated with no errors. Let's take a look. I mean, the numbers look okay. So how does the function call work? We have a variable reassignment of the function L0 or whatever, which is moved into rax. Rax is moved into foo, so foo now contains our function address. So we just do it by calling foo. See, that's incorrect. So a function call is not just going to be call this symbol. It's going to be a variable access. Oh boy. Function call of this symbol, that's fine. Push arguments in reverse order onto the stack. I don't think we actually need to do that, but it's fine. So expression children next child children. Expression is a function call. What is this going to be? So a function call has expression children, which is the symbol of the variable. This is a variable access, right? So expression children is a variable access. So next child, that would be the actual parameters. So these are the parameters. This is making sense. So for every parameter, I guess these are arguments passed to the function call when it's called. So these are arguments. So the iterator refers to an argument, and we code gen each argument and move it onto the stack. That's making sense. So when we emit the call, we are actually going to have to do a code gen expression on, here, I'm going to need a bunch of these things. So for a function call, we would like to code gen an expression, and the expression we'd like to code gen is actually expression children. And we would like to call the register name of expression children result register. How about that? How about that? And it's finished. So now let's take a look at the function call. So you can see the function call to foo has a variable access of foo, because functions are variables after all. And foo gets moved into rax. But this needs to be a load effective address, does it not? It does not, because foo does not refer to the start. It refers to the memory at which the start is located. So we read the memory from there into rax, and then we call rax, and that should call foo. Look at us. We can even try and feed this to as and generate an object file. Feed that object file into LD to generate an executable, and then run the executable. Succeeded with no output. Well, that's quite interesting, is it not? So let's call foo at the very end and hopefully return 42 from this function. From this program, I should say. So now this has all been changed. So now we have a function called foo at the very bottom. And you can see that rax is actually R10, which R10 is actually rax after calling this variable access. Also, we probably need to register deallocate, but it's fine. It is fine. So, yeah, after this instruction, we can register deallocate this. So that way we can use rax again for other things. And then we won't get, yeah, see, that's much cleaner. See, do you see how messy? We were trying to save the value of racks through everything. Much better, much better. So now we move foo rip into racks and we call racks indirectly. So when we do this whole thing and run the executable, shell command failed with code 42. Chat, it worked. Ayo. Foo at the end of this program calls this function, which returns 42. We have officially transformed our language. Oh my god, this took so long. Also, I totally missed an hour ago a follow. I'm so sorry. Defense, thank you so much for the follow. If you are still around, and thank you for joining our epic community. Oh, I did it. It took me 3.5 hours, but I did it. It works, chat. It works. Oh man. This is so good. So good. We still, I don't want to try passing one as an argument. I'm still scared. I don't know if you can tell. RPWH says Pog. Gigabrain, Pog Bones. Hell yeah. Thank you so much, RPWH. You make me laugh. Pog Bones. Hell yeah. So the idea would be that to return an integer, we could have an int function, right, which returns an integer. Oh man. And then we could call int, and then we could say 69, right, is an integer function which returns 69. And then we can say foo of 69. Oh Christ. And then we just need to actually use that one. Invalid syntax, unknown symbol. Perfect. Symbol int. Do we not parse function params in type? Let's think about it. So parsing a type, you can see that we look for a function after parsing a base type. And then we parse all of our parameters, but we're getting some sort of issue of invalid syntax int. And we're saying unknown symbol, which is confusing. It's like we're trying to parse. So we would like to basically, so we get the node symbol, and then we parse type. So why can't we parse type? What's happening? Why no work? Why no do? We have a reassignment of foo to a function. So 69 as a function, all good. But foo is having some issues in that we're getting an unknown symbol int. Oh, it's probably here. This function call is unknown. Well, that's not ideal. How did that happen? So we have int, which should be a function call. Why is it not a function call? A function call is ahead of a variable binding. So if parse get variable fails, we would not see it as a function call, and it would be an unknown symbol. So let's just say if this fails. Just like that. And then you can see not a variable int. But also not a variable foo and not a variable 69. but those are for declarations. So not a variable int, type not found int. So interestingly enough, very interesting actually. So we have this symbol integer, and that is not found. It's not anything. But shouldn't it be a variable? There's a variable declaration. And when something is a variable declaration, we set it in the environment of the context. So maybe for the lambda parameters, so let's look at defun params, and it looks like what we're going to have to do, yeah, see, it's much more complicated. There's a lot to do when dealing with parameters. So we would like to parse a parameter. Also, we need to eat the comma in between variable declarations. That's such a good idea. Look at me. So now in lambda parameters, we got to handle that, right? So if we find a close, we do that. We eat the comma in between variable declarations. Negvorsa says it should be a func type to be called, right? Yes, that's, I think in type checker we deal with that. Don't we compare, string compare with function or something? Yeah, right here. So we ensure that a function call, the variable access that it contains is a function, right here. In any case, I may have misunderstood you. If so, I am very sorry, Negvorsa. I am very sorry. So when we pass the stack to the lambda body, see, each of these variable declarations should be within the proper context, because we have types, variables, functions, types, variables, functions. Interesting. So we're creating new contexts because we have lambdas. Oh, chat. I didn't copy this. That's on me. Yeah, that's on me. My bad. Invalid syntax, parameter list, expected, closing parenthesis, or comma for another parameter. Interesting. Really now. So we parse a lambda parameter. So let's just print node of working result. Actually, let's do stack result, because that's like what we tried to make. And we get so we are now binding the variable, as you can see, because we actually write the proper code, the source code. But the parameter list expected closing parenthesis. So this would be parameter list expected. And this is in fun call. Okay. So that's right. So in a function call, in between the parenthesis, so which function call are we looking at? We're looking at foo69, right? So we should have already parsed 69, and we get this. This should happen. Does this happen? It does not, because then we would return OK. So if this doesn't happen, also we should say if expected dot done, we should like error prep and say, hey, I expected something. Expected closing parenthesis before end of file. Perfect. Parameter list expected closing parenthesis. So we're still down here. Or comma for another parameter. So are we saying expected.done? Is that what's happening? So comma probably should be optional, right? Now we just exit with code 5. We're just going to go right to the debugger. I am too far, I'm too deep to deal with this. Did it just work? Excuse me, you're supposed to tell me what goes wrong. God damn it. It's fine. It's fine. We'll figure it out. What's going wrong? So hopefully it's not just as simple as that. It's not. And interesting. So when we are in a function call, we're trying to continually get arguments. What is this? What is this? Okay. We're just gonna fix this up because this is messy. That's a little more clear. Yikes. Still don't work, but it is a little more clear. So stack equals stack parent. We do create a fun call stack, right? We say stack, parse stack, create, blah, blah, blah. We don't say continue, which would be a big deal. I'm pretty sure. So this is a function call. We have a variable access as a child, which is what this does. We have parameters as the next child. And then all of these, ooh, okay, I think I see the issue. But in the type checker, we're doing it differently. Children. See, expression children, next child, children. Okay, that wasn't it. Maybe it'll help us. It did. Value children next child was null putter. What is value? Am I mistaken? So only type check parameters when they exist. So we need to ensure that next child exists. Okay, why doesn't next child exist? So we're creating a function call. This is where we are, right? Function call. Trying to type check the parameters. The parameters are stored in the type of the variable being called. So we have the variable being called type in value. And that will have like a, what? Value. It's a symbol, which is function, which has a child. And this child is a symbol, which has integer. And that's it. So it's a function which returns an integer. Next child is null. So when we have no parameters, you can see that we don't even get a parameters thing. See, like, shouldn't we always have this? It's kind of confusing to me how next child can be null. Because working result is the function call. It has the variable access as a child. and it then has the parameters as another child. So value, see, but this the type. This the type. That's the thing. This isn't the function call thing. That's expression. This is value. Look at me being dumb. So value has parameters, right? I sound so dumb. Value has parameters. So value contains our type, which if it does contain parameters will be here. Also probably back to invisible. Access denied. Wonderful. Oh, it's probably to do with this. We need a different, see? I'll always remember eventually. This damn debugger. Perfect. Type compare symbol. Access violation reading location 0. Type compare symbol called on non-symbol nodes. Okay, so I think we might know what's going wrong. And now, at this point. So A is just a symbol integer. Okay. B is just an integer. So B is not a symbol. Where did this come from? Type check expression of function. What? So type checking this function, we're trying to compare the return type of the last. Why is this not a symbol? How did we get integer? So maybe a function call return type is what's going on? How did we get integer? What is last expression, right? Somewhere down here. Last expression. Type of 4. I don't know what that is. So type of 4 would be 0, 1, 2, 3, 4. A function call. What do you know? So the last expression is a function call, and its return type is not a symbol, it's a resolved symbol. So we screwed up somewhere in type checking of a function call. What is this? Value children next child. So this is our, I think it should just be this. Not gonna lie. Wonderful. Another code 5. We're having a lot of progress. Let me guess. Called on non-symbol nodes. So called from here. Last expression is what? It's a function call, so expression return type is what? It's what? You won't. It's 0. It's invalid. None. God damn it. Okay. So expected type symbol of parameter is probably just expected parameter, but whatever. This is going so wrong. Still not a from here. Gotta run it from here. Okay, wonderful. So we get B, which has, it's none. It's literally just an empty node, B. Why would we call this? How? So B is expression return type. An expression return type is somehow none. Even though the last expression exists. See, the last expression is a function call to the function int. Right? Okay, that all tracks. Function call to the function int. So why don't we return the proper value? So we're trying to do a variable reassignment, type check an expression of the right-hand side return value. Is that true? So we're type checking this right-hand side of this variable reassignment. And in that, it's a function. That's proper. So we type compare the symbols of the last expression in the function and the actual return type of the function, because we want to make sure that those match. But instead, expression return type is nothing. So a function call isn't setting its proper thing. So let's start a little bit of a breakpoint. Function call. Can we break like in here? Actually, shouldn't we see these printouts? Why don't we see those? That's a little suspicious. I feel like we should see iterator and stuff. In any case, function call, set a breakpoint like right here, on break, ironically. And we reach the error before we ever do anything, which is confusing because you'd think that we would have to type check the body expression, which was last expression, which is a function call. So type checking the function call into expression return type, you'd think would make expression return type return the actual return type of the function call. No? The return type of the function. But it doesn't work like that for some reason. What is going on? So value children next child. If there's no parameters, we're not setting the result. So that's our little issue there. Right? See, we need this break outside here. Type of left-hand side variable reassignment must match right-hand side. So left-hand side is a function integer, function integer. And the right-hand side is a function integer. So the left-hand side type is a function which returns an integer. And takes in an integer function as an argument. A function that returns an integer. Yes, yes. And then right-hand side type, it says function integer. So how did this get differently interpreted? Because the return type of this is not function integer. Also, Liko said your debugger is not showing on stream. My bad, I think I fixed that a little bit ago. But that is my bad. I did notice that earlier. So type of left-hand side of variable reassignment must match right-hand side return type. So we've gotten to a variable reassignment. And the reassignment is of foo to this function. Which returns an integer. So the reassignment of foo to this function is causing errors in the type checker because the left-hand side does not match the right-hand side. So the left-hand side is a variable excess of foo. Foo is what? A function which takes in an integer, or returns an integer, and takes in a function which returns an integer. Pretty self-explanatory. That's what this is. So why does the right-hand side type not match that? I feel like that's a little bit confusing there. So let's go ahead and try to wrap our heads around this. So in Parser, are we not setting the type correctly? Maybe that's in type checker. So type checker, the right-hand side type is a function. So what is the result value set to? It's set to a function type symbol with expression children. So whatever the function returns as a child. So interestingly enough, we don't include parameters in this type. No? Yeah, we don't. And we need to. So now this will be return type of function as first child. And this will be types of parameters as following children. So how do we get the types of the parameters, right? So we type check the body of the function. What does the function look like? This. So the parameters, first time chat from a new viewer, Hawakau says, yo, finally caught the stream live. How's it going, Hayakayu? He gives us an egg or love. I love you too, buddy. Thank you for showing up. Thank you for tuning in. How are you doing? I assume that you came here from the YouTube. So this function has its parameters, right? So we should also ensure that they're all variable declarations, but it doesn't really matter. So how do we do this? We have the symbols of all of our, we have the names of all of our variables, and we are within the proper context, right? So our context is our context to enter. So all we have to do is say parse get variable, right? And the variable would be this variable declaration. Is this making sense? I think this is making sense. Parse get variable. Why is it not helping? Do I not have this? I have parse get variable. It's just probably not in the header. Yep. There we go. Get the value of a variable. Symbol ID in variables. Environment. Perfect. Hayakayu says, yeah, I'm watching the series by having it in the background or when I just want to chill out. That's awesome. Hopefully you learned something. Hayakayu says, love the 20-minute tangents the most. Yeah. We definitely just totally get distracted and go, ooh, what was I doing? So we're going to have to do this for all parameters. So this is going to be expression because we're type checking a function. children next child. So function children next child. Children. Yeah, if you have any questions, I'd love to go off on a 20-minute tangent for you. So parameter, and then we would like to get this data into like param type info. We'll just do parameter type. I think that's better. And if there's an error, return the error. Okay, so effectively, hey, Elite Assassin 07. Hey dude, it's me Monkey on my PC account. It's so good to see you. Elite Monkey. How's it going, Elite? I am glad to see you. We've definitely made a lot of progress since you were here last. It's been some time. Variables not found in environment. Which variable? So let's print node parameter and figure out what the hell's going on. I see, so it's probably null. So I should say if, yeah. Okay. We're going to do this, and we're going to say if parameter, and do this stuff. So if there are parameters in the function, do a thing. Variable is not found in environment, because we're just using the parameter itself. And now, right back to mismatched types. Look at us. RPWH says, I finished my keyb. Ooh, that's awesome. RPWH is a supporter of the channel and has finished his custom keyboard. Ooh, can we... Ooh. Wow, that's beautiful. That's amazing. Also, I love the keycap choice. The colors are very good, and I like the font. So are these like orthographic keycaps, or are they OEM? Like, which profile do you have? Because they look like they're all flat like a typewriter. It's cool. Elite Assassin says, dang dude, you got 11 viewers? You becoming a big streamer. Lol. It's true. It's true. We growing. We out here growing. We excited. We're always excited. This is so cool. I can't believe this is real. Ooh. It's got to sound so amazing. It looks so amazing. We definitely need a keyboard thirst emote now. Ooh. I love it. I love it. Hayukayu says, also, to be fair, it's kind of sad you haven't streamed the OS development, since I personally find OS more interesting / complicated than compilers. Yee, we just been working on this compiler for a month. We'll do other things, I promise. RPWH says their cherry profile. Ooh. They just look very flat. I don't know if it's the image, but they look very nice. Thank you, RPWH, for answering, by the way. This is a cool layout, too. I like how you don't have an entire numpad, but you have, like, the keys that are generally found over there. Like, delete, page up, and page down are very useful to have, especially when you don't have them. I like the double alt, double control. Very pog. Very pog. This is so cool. And I can't believe you hand-lubed each switch. Like, that sounds like hell. Did you lube the stabilizers too? Are you that insane? Okay, so now the right-hand side type is a function, which should return an integer. So this is function integer. But we now need to, when we do get this parameter type, right? When we do get this parameter type, also we should say, like, if parameter type does not equal no type variable declaration, big problems. So error prep, error for an error type, and this is going to be function parameter declaration must be a variable declaration. I don't know if anything other than this is allowed, but it's fine. Eternal Wild Fox says, at Lenzer, what you can do, I pick one day in the week for OS dev, for example. What? That might be a little too far gone. I'm trying. What you can do, I pick one day in the week for OS dev, for example. Oh, okay. I see what you're saying. I see what you're saying. That would be fun. I would love to learn how to program an OS. Thank you. Thank you. I see what you're saying now. So you're saying that pick like one day a week, just not so often, but every once in a while, and say, hey, I'm going to stream OS today, and then we'll get back to the compiler. That's a good idea. Kind of slice it in. Negvorsa says, me too, but both are fun to learn. Alrighty. I'll definitely keep that in mind, that there's some demand for OS dev. And I will, I'll look into that and try and make time for that in the future. RPWH says, the stabilizers came pre-lubed, but I did buy dielectric grease for them. Nice! That's good you didn't have to go all the way. Lubing stabilizers is like the end of the world. I gotta deal with a text on my phone, so I may be a little quiet, but I am still here reading chat and everything. Okay. Okay, so yeah, that would be fun to do some OS dev on stream. I'd have to know what I'm doing though. Most of the time for OS dev, I just open up the code base and I just look through it and go, oh, there's so much to do, oh god, and then I pick something and I do it. Okay, so we have to add, oh Christ. Don't you love right when you set your phone down and you forget that someone's going to respond right away? Not you forget, but someone responds right as you set your phone down. It's like, ah. All right. We're good. We're good. So we would like to have our type. You can see that this function integer, it just needs another function integer because the parameter is not being added to the result. So we need result type to get a new child every time there's a parameter of the parameter type. That went horribly. Why? So maybe we'll do something like this. We should really have like a node copy, no children type of thing. Okay, nope. So we're gonna go back to the debugger. A was null pointer. So now doing type compare on a null pointer. Where are we doing type compare? Are we doing type compare and not type compare symbol? What? Where were we? What were we just looking at? This is type checker in function call. Am I blind? I must be blind. See, we're in function, but it's in function call. Again, not sure why they're not next to each other, but that's fine. So we're using type compare instead of symbol. We need to type compare symbol. Still didn't fix, but at least it'll help. We're still getting null, but it helps. So we got our warning, called with null args. Hayawakao says, I still don't know how to say your name. Hayaku. Yeah, I know. Working on a thing continuously from ground up means you have everything in mind and can work well, so going back to OS would be hard. Yeah, it's also just like, I'm at a point in the OS where every step is like a week of work. Just because I'm so late into the process and I'm just one guy. So A was null pointer. That's no good. That's absolutely no good. How was A null pointer? We're type checking a function call. And expected parameter. See, I gotta open up my goddamn... Does anybody know what it is? It's not output. It's the one with all the things in it. Yep, not that. That's not ever useful. Gotta love Visual Studio. So we're looking for debug variables. Jesus Christ. There we go. Locals. Expected parameter. Where are you at? It's 2. That's a symbol, which is a function. So expected parameter is function. So we no longer need... Okay. So a function call... Negvorsa says, I think you should compare the return type with the arg type in the function call. The return type with the arg type? Why would we do that? The return type of the function and the arguments you pass to it should be separate. Hayaguao says, it just, compilers feel so linear, like you put the stuff in good structure and then you apply a couple functions and you're done. Okay, let's see you build one like that. Whereas OS is a lot more unexpected and tangled, and it's also a lot more complicated to start because parsing strings and doing something with them is ComSci 101. Sure. RPWH says, wait, I was wrong, they're XDA profile. Ooh, okay. So they are flatter. Okay. I knew it, RPWH. I was like, wait a second. Those look like typewriter keys. Eternal Wildfox says, compiler isn't just as simple as you say at Hayakoao. Eternal Wildfox is correct. Liko says, optimizing CodeGen isn't straightforward. Not at all. Eternal Wildfox says, to be honest, I built a simple Lexer and parser in C on day 2 of learning C. RPWH says, yeah, they are, lol. If you think a compiler's straightforward, I would love to see you build one. And show me how straightforward it is. That's all. That's my only response. And if you do think they're simple and you have built one, I question your sanity. Because nobody would look at this code and go, oh yeah, this is simple. Function calls. Iterator. And expected parameter. So expected parameter is value children next child. Yes. A was null putter because what was null putter? Expected parameter children next child. So what if I just use expected parameter? Why are we doing children next child? Hey, look, we're type checking. Chat, we did it. Our downwards fun arg is starting to come into fruition. Elite Assassin says, by the way, I finished my Minecraft macro, made a GUI and everything. For real? You're gonna get all that sugar cane, my guy. That's insane. That's really cool you made a GUI for your Minecraft macro. Neg Vorsa says, by return type, I mean the last result type, not all the children. I see. So result type, basically value points to a function. We've ensured that, right? So the child of value, I may be misunderstanding you, I'm sorry, but the child of value should be the return value of the function, which is our result type. I think that's okay. I think we're okay. And now we just need to do the same thing during a function and say our return type may have any amount of parameters. Right? So we need to say while parameter equals parameter next child. How about that? And within each one of these, we would like to populate, we'd like to first ensure it's a variable declaration, then populate. Also, this should be a do. Okay, so we have parameter, so we do make sure it's a variable declaration, get its type, and add its type as part of the type of the signature of the function. Now we just have could not get local base pointer offset of variable. That's okay. I wonder why we don't get that. Why would we not get that? So in code.s, you can see that we have a variable access int. So int is actually what? It should be a stack, something on the stack. So it should be like 16 off of the base pointer, accessed within L0. But then we did L0, so we have L1, and in L1, we're trying to have a variable access of int, where we load the effective address into racks of L1. That's totally fine. So after the variable access of int, shouldn't we just have a function call? Because that's its... This is the function. So this is this done. Or at least it seems like. How is this happening? How are we loading the local address, the local symbol 1 address into racks for the variable access of int? See, this is a little confusing. I would admit that fully. So if we look at CodeGen, what are we looking at? Variable access. So if it's a local variable access, see, global variable access is easy. All we do is basically say, hey, there's this thing, and do it. Like there's a name, it's a symbol. We already have the symbol, just access it. That easy. For a local, we try and get the stack offset from an environment of locals. And if it says could not find blah in local's environment, that's not what it says. It says could not get. Which is so interesting. So we're here. Okay. I don't know how we just had two variable accesses. I don't know. I'm confused. It doesn't matter. Also, I've been streaming over 4 hours. Now is a good time. Check out the Discord. We have a ton of fun. Ooh. Ooh, here's your your Minecraft loop. That's right. Very cool. It's very clean as well. I like all the... It's just easy to read. Very cool, very cool. But yeah, be sure to... Where did the general text channel go? I was like, wait a second. But join the Discord. There's a ton of people. It's a ton of fun. I really recommend it. And we're all friends here. We all have positive times. You can share whatever you're working on or anything like that. So I'd recommend joining. This is in the About section of Twitch, and it's a ton of fun. There is also a link to the YouTube, which has all my previous broadcasts, a link to GitHub, where you can find this code, open source, available for free. You can do whatever you want with it under the MIT license, and just do whatever you want with it, effectively. And yeah, check out the GitHub down below for that, as well as the donate button. I would greatly appreciate any and all donations that come in. If you leave a message, I'll read it on stream as long as it's appropriate. And if you leave your name, or your username, I should say, I'll even attribute it to you and say, hey, this person donated this much. Thanks to them. Our most recent donator is RPWH, so shout out them. They're actually in chat right now. Shout out RPWH. Give them a pog chant. Pog bones. Pog! Because they're an amazing supporter of this stream and are a large reason of why we continue on. So thank you all for watching. Thank you all for donating if you can. If you can't, don't worry about it. All that I care is you are positive. RPWH says, hi. Hi. Wave to RPWH, everybody. King Buns says, thank you for your stream. Thank you for watching, King Buns. I'm glad you enjoyed it. And thank you for thanking me. Gnarly Quack says, soon to be showing up in your auto code completion, Lenzerlang. Oh, I don't know what the name of it is, but you're right. Okay, so a variable access for a local variable. See, the problem is, if we get the stack offset like this, yeah, see, here's the issue. If we get the stack offset, it'll be from the base pointer of the context it's in. So we'd have to access, like, each time we do this, have our result register. We have to move into it. Our base pointer. And then at the end, we would offset from that into our final register. So we just need to get our proper base pointer, which we can do by accessing the base pointer. Oh man, this is going to be complicated. RPWH says, thanks for the stream. Thank you. Thank you. I think what we're going to do is we're going to do some commit, and then we are going to close up shop for the day. I've been streaming over 4 hours, and I am tired. My voice is gone, and yeah. But we've made a lot of progress, and I'd say it was very worth it. And we can, in the type checker, we do that. We're just going to call these developer warnings, and they're basically going to say, hey, you screwed up as a developer. Right? That's it. RPWH says lens script. I mean, that's the leading one. We got lens script. Lens script, baby. Okay, so what I'm thinking about doing is for like the next 3 months, if you donate over $20 or something, have it where you can change the name of the language or the compiler. So like if you pay $20, no matter who it is or when it happens, just the name changes to that. We go through the README, we go through everything, and we change it to that. And just the most recent donation, over $20, that suggests a name will be used. I'm thinking about doing something like that, because I think that would be cool for you guys to be able to, like, you could have wars with each other. Like, ooh, this person, I'm gonna pay, and I'm gonna make it LensScript. And then another person's like, nah. It's actually Blaze. And obviously we'd have to have rules, like it has to be appropriate. And there has to be like community guidelines that we don't want any hateful speech as the name of our compiler. I don't think that's even funny. So, but some people probably do and would try to do it. But overall, I think that's something to think about. Defun. So we no longer need defun of any kind. We have no more fun. No, but we just don't need defun. Symbol is unknown and is not followed by an assignment operator. Perfect. Just doing a little bits of cleanup so that I can commit the commit. Okay. Liko says, Gnarly Quack says, maybe just L? This language is so dope, we jumped from D right to L. Lamau. There's actually an F, there's an E. There's a lot of languages that are just single letter. Liko says, should be a W then. Oh! Jumping right to that W. Okay. We're definitely going to need these changes, not that one. Lambda body and lambda parameters, definitely needed. Get rid of defun params. Keep fun call. Change fun call a little bit. What is this? Okay, that's parse type. Changes to parse type. This is lambda checking instead of defun. We get parse get variable. And I think that would be a good place to start, but it would make a very broken code base if we did commit it. So I'm just going to commit everything from type checking and code gen as well. Otherwise we'll do a bunch of null dereferences and everything will kind of be broken. Hopefully I did not forget something obvious. And if I did, hopefully it's fixable. We do calls differently now. We do function return. So in CodeGen, what should function return? Function returns beginning of instructions address. Perfect. Gnarly Quack says, or just stick with the C meme and call it C sharp. Or no, not C sharp. What is that? C flat. That's right. I always forget. We could just call it C flat. But it's more like C not flat because of the nested function things that are happening. Okay, so then this code gen we gotta do. Why did that just happen? So we have comments. We'll stage that. And that looks good. The rest are comments. Okay, we're just gonna commit this little thing and say completely overhaul. Yeah, we're just gonna say overhaul. Functions are now closer to first class citizens. Woo-woo! They aren't yet, but we are for sure getting there. Still some minor, let's say, troubles and inconveniences. I don't know how to spell inconveniences surrounding the funarg problem, but overall, we now have functions represented as variables with the signature as the type. And it works great. Perfect. We're going to pretend it works great. And then, oh, did you, oh, I can't speak. Oh my god, I'm dying. Okay. Hopefully I can speak now. Jesus, every time I tried to talk, it was just my throat got even more scratchy. Gnarly Quack says, fittingly, inconvenient is not a very convenient word to spell. That's true, very fitting. So we will push our little problem. We have broken all of the examples, all of the example code with this change, so sorry. Code's different now. And yeah, so we are much closer to having functions as first-class citizens. I don't think we wrote this anywhere. We did not. I just wrote it down last night on paper. In any case, we did it. We actually can run code. We can't pass them as arguments yet. But type checking we can do. It's just that when we try and generate the code, it doesn't actually work. There's one more step and then it will be fixed. Gnarly Quack says, drink. Gnarly Quack. I like that commit message better. Broke everything. Lol. Yeah, we did. We broke every single example because they use like the this syntax, the fun, which we literally just removed. So, goodbye. Oh. It's okay though, it's okay. Everything's fine. But yeah, so we can now actually have the downwards funarg problem not quite solved, but we can accurately call functions in a new way where we can define them as variables and reassign them to lambdas. And the lambda can be called at any point through the name of the variable, which is very cool. And eventually we'll also support calling lambdas directly, like doing something like this. I don't think this would work in our language because you can't do address of, but this is fine. And this would return a value, hopefully. So if it was just an integer, we could return n plus n like this. And then we'd have to pass in our argument. Very cool. But yeah, we're getting there. It's working. Gnarly Quack. Removed all defun. Only fun is allowed in this language. Yes. No defun, only fun. So good. But we can compile this example, which calls foo, of a function defined like this. It generates this code, and we can call this code with our little incantation, and boom. Failed with code 42, which is exactly what we would expect foo to return, given that's what it returns. Gnarly Quack asks, what's all the at and at? I see you haven't been around a while. So we have a pointers example now. So you can see that we actually have pointers. So an at is the dereference symbol and the pointer declaration symbol. So Gnarly Quack says, sorry, I'm not really up to date on everything you've been working on with the language. It is all good, don't worry. I just have to know what knowledge you have so I don't tell you stuff you already know, right? But yeah, basically, this at is an integer. We implemented it in like episode 18, the pointers episode. And this at means that this is a pointer to an integer. So this test putter is now not able to be assigned an integer, but you can assign it to an address of another variable that is an integer, like a or b. So now test putter is a pointer to b, right? And then to dereference the pointer, you can use this at syntax, because pointer is a pointer to an integer, so dereferencing the pointer gets you an integer. So this writes 69 to the memory pointed to by pointer, which is actually the address of A. So this updates A to be 69. And then we return it at the end of the function, which means that this returns 69. And if this reassignment and stuff didn't work, then it would be 42, because we dereference putter again, and yeah. Gnarly Quack says, oh, so at instead of star, basically. Yep, exactly. Any particular reason you picked at? You could go watch the pointers episode. I had a lot of discussion with the people in chat. But at is both easy to type on keyboards from the US and not from the US, and it's also it's used as pointers in other variables. So at is kind of like, oh, this is the memory address at integer, if that kind of makes sense. Or like at pointer, write 42. So it was both to make it a little bit more readable and also just have a unique symbol that is typable on all keyboards. And I also didn't want to use multiplication because I want to keep that as 2 times 3 and stuff like that. I don't want to have a unary multiplication operator just for dereferencing and creating pointers and stuff. Gnarly Quack says, cool, yeah, you can just give me the TV guide summary. Lamau. Nah, just watch like the 6-hour video on pointers. You'll find the answer to your question in there. Not really. Well, you will, but I'm not saying to do that. So we can now compile, we can run, and we can get the proper answer. Hey, you can make it small. I didn't know that. There we go. We did it. Anyways, chat, that is it for us today. We have officially done everything we need, and it is now no longer time for welcoming. It is time for our goodbyes, our salutations. Thank you so much, everybody, for watching. Like I said, check out the Discord down below, that donate button. If you can, I would greatly appreciate anything. Even if it's just $1, it would mean a lot to me. I don't have any other source of income, so it piles up. It adds up, right? Even if it's pennies. So thank you. Thank you so much. And yeah, be sure to check out anything you are interested in. Stay tuned. Hit that follow button. Do all of the things. And I promise we'll get this compiler. We'll get this compiler working. Negvorsa says thanks. Thank you, Negvorsa. Gnarly Quack says thanks for explaining. Thank you for asking. It is your interest and your attention that actually allows this channel to function at all. So I greatly appreciate it. Gnarly Quack says, enjoy the rest of your Labor Day. It's Labor Day? No, I'm just messing with you. Elite Assassin says, see ya. Bye, Elite. Bye, Gnarly. Bye, Neg. Liko, King Buns, Eternal Wild Fox, RPWH. Shout out to him, the contributor, the POG contributor. Oh, yeah. We got Hayo Guau. I don't even know how to say that name. Who else did we have in here? We had, I'm going to scroll up. Restinisis. We had Restinisis. We had Nick in here earlier. We had Lil Weege, Adderson. Ooh, Rohan. So good. So good. Thank you to everybody. I love you all. And I will see you in the next one. Bye-bye. Love you. Bye.